Please welcome Polly Bott.
Hello, everyone. Thrilled to join all of you today because we've got a very exciting topic to talk about and fantastic line of speakers and demos. Today, we want to talk about cloud DevOps, right? So when we talk about DevOps, most people think this, which is it's a great way to connect the development and operations teams and bridge the gap. Yes, this is true, but DevOps is a lot more than just that. Ultimately, what DevOps can do is get your business more agility. And it can bring feedback from all of the downstream systems, including your customers, back into the development process so that you can build great solutions for your customers. So as we think about cloud DevOps at Google, there's 3 principles that we keep in mind. The first, of course, is how do we increase developer productivity? Because that's what we're all here for. The second bit, which is just as important, is getting all of that downstream feedback and shifting it left so developers have access to it earlier in the cycle. What this lets you do is avoid those costly mistakes and catch them much, much sooner. And the third piece, which is just as important, is scaled operations. What the cloud lets you do is run your business at scale, and cloud DevOps should enable that. So we're going to talk a little bit about each of these 3 aspects and then dive into a fireside chat as well in a little bit of time. So first, let's talk about how we increase developer productivity. As we talk to our customers, the number one thing we're hearing from them is, yes, they've looked at cloud as a way to lower their costs, but they want a lot more than just that. They want greater agility for their business. And the way they want to do this is by building cloud-native applications. There's been a huge surge of interest in this, especially around Kubernetes. Unfortunately, though, app dev teams across a number of our customers are still working on traditional IDEs that are optimized for local app development, those run on-premise. And one of the challenges with this is as you use these local environments to build cloud-native applications, you frequently end up with either more complexity or errors that are caught too late in the cycle. So to solve this problem, we announced Cloud Code yesterday. And what Cloud Code lets you do is rapidly build, debug, and of course, deploy these Kubernetes applications. And the best part is, you can do all of that right within the context of your local development environment. So think of this as a power boost to your IDE, and we've shifted left all of the complexity, and we've abstracted it away so you can actually just focus on building cloud-native apps. So to tell you more about this, I want to welcome on stage Jez Humble, who's part of our developer advocacy team. Jez?
Good morning, everyone. So first thing I want to say is if you get one of these cards, and I'll be giving them out afterwards, 25 minutes of your time, we really appreciate it. It helps us understand how to build high-performing teams. So please grab one of these. Thank you very much for your time. So how many people in this room are building code in Node or Go or Java or Python? OK, that's a lot of you. Great. And how many people know how to set up and manage a Kubernetes cluster? OK, that's also a lot of you. That's great. How many of you are going to be working on Kubernetes in the next year? OK, almost everyone. So that's great. Kubernetes is the industry standard infrastructure for building cloud-native apps. But if you're anything like me, you might find Kubernetes a little bit intimidating to set up and manage. You might also worry about the impact on your productivity. My favorite experience as a developer is being able to hit save in the IDE, switch to the browser, hit refresh, and be able to see pretty much instantly what I did so that I can check that I'm on the right track. Microservices and service-oriented architectures also add complexity, and we want to create a simple way for you to stand up some subset of your production environment for development purposes locally. So today, we're going to show you Cloud Code. Cloud Code lets you develop codes in VS Code and IntelliJ and get a seamless, near-instant developer experience that mimics what you're used to, that local developer workflow. So to show you that, we're going to build and deploy a simple distributed system. This is a guestbook, which is going to talk to a microservice that does translation of the comments in the guestbook into different languages. We're going to start off by building and deploying the translation microservices. And Dan Larenc here is going to show us what that looks like in Java using IntelliJ.
Thanks, Jez. Thanks, everyone, for coming. Everyone here has heard of terms like continuous delivery, continuous integration, continuous deployment. Today, I'm going to be showing how to use Cloud Code for IntelliJ to set up a continuous development loop, where I can edit and save my code locally, and it's going to get deployed and running inside of a cloud Kubernetes cluster inside of Google Kubernetes Engine. So right here, we have a cloud-native guestbook application. It's a very simple Hello World service that is written in Java and is printing out Hello World over HTTP. We can see that this is running in our continuous development loop, so it's running here inside of a remote Kubernetes cluster in GKE. We can refresh, see that we have the message. I'm going to come in here and change this message and press save. And this is where the continuous development loop kicks in. So we can see here below that Cloud Code is watching this code for changes, detected that I saved this file, and starts to automatically rebuild, repackage, and redeploy this up to GKE. So this code is turned into a container using our fast container builder called Jib, which knows how to optimally rebuild and repackage a Java application and get it running in a container registry. All right, so this should just be about to finish up here. And we can refresh and see our new message. So we were able to make this simple edit and get it running in GKE very quickly. This is the basic app, though. This isn't the translation backend that Jez talked about before. So to turn this into a translation backend, I'm going to first add some client libraries and enable some APIs so that we can use the Google Cloud Translation API. I'm going to do this using another feature of Cloud Code. We can come in here and add cloud libraries and manage cloud APIs. I'll click that. This is the translation backend. So I'm going to click here on Cloud Translation. And there's a feature here to automatically enable the API on GCP for us, so we don't have to leave the IDE. I'll click Continue. And this next dialog is a way to have Cloud Code automatically create a service account and secret so that you can talk to this API. Since we're running in Google Kubernetes Engine, though, we don't need to use this. I'll click OK. And now Cloud Code has automatically added this dependency to our application, added it to our pom.xml, and started to rebuild and repackage this again for us. I'm going to switch this code out for our translation backend. And while that gets redeployed, I'll explain how this works. Here's the main function here. It takes in some strings over JSON on HTTP and first passes them to the translation API to detect the incoming language. Next, based on what language it is, we translate this to both English and German. And then at the bottom here, we do some debug logging to system.out. Awesome. This looks like it's about finished, and we can try it out here. So I have some text saved that we're going to send in as a translation. It's a couple strings.
And of course, this is a live demo, and we'll have a blameless post-mortem afterwards.
Here we go. So a couple strings get passed in, one in English, hello world, and a sentence in German. We can see that these are both translated back into English and German. And the final cool feature is that Cloud Code automatically streamed these logs from GKE back down to our IDE, so we don't need to go anywhere else to see debug logging.
So not only did it deploy into Kubernetes without you having to do anything, it also streamed the logs back into the IDE for you. And that would have been hard to do on your own. It's great stuff.
Awesome. Yeah, so we got this simple translation back and running. Now we're going to look at how to use this in a bigger distributed application.
Thanks very much, Dan. Woo! Yeah, live demoing is terrifying. So obviously, in a real system, we're going to have more than one service interacting. So now we've got our translation microservice live. We're going to build this guestbook and deploy the guestbook, which is written in Node.js. And Vijay Subramani is going to show us how to do that using VS Code. Take it away, Vijay.
Hi, this is the, hi, thanks, Jez. This is the guestbook application that Jez was mentioning, where users can add guestbook entries in a language of their choice. And we'll go ahead and integrate this with the translation service that Dan has built to display English and German translations for these messages. And I'll be using the Cloud Code plugin for VS Code. And I'll go through one cycle of the inner development loop, make 4 quick code changes, deploy them to the remote cluster, and troubleshoot if required. So the first change, I'll make it in the display template to add some style sheets that are required. Next, I'll go and add some placeholders for the English and German translations. Then we'll go to the app.js file and tell it that it can find the location of our translation service from the Kubernetes environment variable. Then we'll add the main logic to call the translation service for each of the guestbook entries. It's a straightforward loop. We'll add some error handling as well. And then finally, we'll publish the location of our translation endpoint. And then we'll go ahead and save our changes. And the continuous deployment has been monitoring for your changes, and once it's detected them, it's packaged them and sent it over to the remote cluster for deployment. And as you can see, the deployment has already finished. And let's reload this. So there you go. We have our English and German translations. That does not look like German, does it, Jess?
Nein, das ist nicht die deutsche Sprache.
Okay. So let's go see what's happening. So the logs that were in the remote cluster are streamed directly back into your IDE, so you don't have to go around hunting for them. So from the logs, we can see that German messages are indeed coming back from the translation service. So that service communication is working fine. So must be something going on with our application. So why don't we just try to debug? Let's set a breakpoint here, and let's start our debugger. And the debugger attaches against the running process in the remote cluster. So let's go ahead and reload our application. Boom. The debugger breakpoint has been hit, and we didn't have to do anything. This is against the remote cluster.
That's amazing. So we're debugging using the regular IDE debugger. In the Kubernetes cluster, we didn't have to create any launch configurations, write any YAML, do any port forwarding. It just worked from within the IDE. That's awesome stuff.
And this is a fully featured debugger. You saw me stepping through it. You have the watch variables. You've got the hours. You can even inspect the variables. So from this, I can look at the temporary translations array that the code is building. And I can see that the German translation is reaching my application code. So maybe we're missing some kind of assignment statement somewhere. So let's go ahead to our debug console and hardwire one of these assignments and see if it gets reflected in our application. So we hardwired for one of the entries. So, oops, and let's let our debugger run through. And there we see the entry that we changed is being reflected in our application.
And once again, that's changing the state of the live system from within the debugger. Cool stuff.
So it looks like we're missing an assignment statement somewhere. There it is. So let's go ahead and fix it. And let's save our changes and stop the debugger. And Cloud Code would have picked up these changes and would have already started packaging them and started deploying to the remote cluster. And as soon as it finishes deployment, we can reload the page.
And obviously, the IDE takes its time, especially when there's a demo. That's a built-in feature. If you're demoing, it adds a special lag just to make your life difficult.
So it'll reload the page with the right entries. So what you just saw was one cycle of the inner development loop. We made some changes, we deployed them, we debugged them, and you didn't have to touch any Kubernetes configurations yourself. Cloud Code handled all that for you in the background.
Cool. Thanks very much, Vijay.
Back to you.
OK, so once you've got your service live in production, obviously you have a whole team that takes care of it. And Ben is going to be talking about SRE later on in this segment. So one of the key concepts of SRE is SLOs, or service level objectives. And these are targets for the health of your application that represent something a user would experience, not a proxy variable like CPU usage or memory usage. And once we have SLOs, what happens is our application breaks them, and we get woken up at 4 o'clock in the morning. So I've been woken up at 4 o'clock in the morning because our application has fallen below its SLOs, and I'm going to ping Christy Wilson, who is on call for this app, and she's going to work out what's going on so that we can remediate and get everything working again. Over to you, Christy.
All right, so it's 4 a.m., I'm on call, and I've been paged. I need to figure out what's going wrong in production and fix it as quickly as possible. So to do that, I'm going to use Cloud Service Mesh, or CSM. So CSM is currently in alpha, and it requires Istio. But out of the box, I can take a look at things about my running services, like the metrics. I can look at the logs. And I can look at other telemetry data as well. And I can create my own custom SLOs. So here we can see that I've already defined one for 95th percentile latency, and it's being violated. And since I'm looking at the front-end service, I have a pretty good guess that the reason I was paged is because the front-end service is overloaded. So I need to mitigate this as fast as possible so I can get back to bed. So to do that, I'm going to use Cloud Code. So Cloud Code can be used by all kinds of engineers, whether you're wearing your developer hat or your operations hat. And so what I'm going to do is I'm actually going to take a look directly at the production cluster in the Cluster Explorer. Now, obviously, not all developers should have access to this, but I'm on call, so I do. So in the Cluster Explorer, I can start looking at what's going on in production. I can see my deployments. They're all green. And I can start diving into individual pods. I can look at the containers in those pods. And I can see details like what environment variables they're running with, what the status is, and I can even get the logs from my production cluster right in my IDE. And if I want to, I can even connect a terminal and start executing commands in my production containers. So one thing that I'm noticing as I look at this is that our overloaded service only has one replica running. And since it's overloaded, I'm thinking maybe a way I can work around this is to increase the number of replicas. So to do that, I'm going to use this edit icon here, and I'm actually going to bring up the production configuration right in my IDE and make a change. So I want to increase the number of replicas from 1 to 10. But I'm tired, so I made a typo, and I put the value in wrong. But fortunately, the IDE has my back. So it's telling me, because it's aware of the schema, that the type is wrong here, and this should be an integer. So I can make the change I meant to. And because it is aware of the schema, the IDE can give me IntelliSense and show me what values are valid at this point in the configuration. So let's go ahead and save that. And the IDE prompts me to warn me that it's about to apply this live to a production cluster, which, yes, I did want to do. And in the Cluster Explorer, I can refresh, and I can see that Kubernetes is immediately doing what it does best and scaling out the 10 replicas that I requested.
So any ops people, SREs or sysadmins are probably having a mild heart attack at the moment watching Christy change the state of a live production cluster from her IDE. And in fairness, that wasn't a feature we'd originally planned. We got feedback from our early access users that they wanted this functionality. And in fairness, it's super useful if you're managing a dev cluster or a test cluster. It's really, really helpful. However, in real life, what we want to do is make this change to version control, push it out through a deployment pipeline. This is the paradigm known as infrastructure as code, or GitOps. So Christy, how would we do that?
Well, let's take a look at the files in version control. So this is the deployment in version control, and as you can see, because of my emergency change, it has fallen out of sync with production. So I'm going to make the change here. But before I do that, I can show you some other Cloud Code features. If you've been working with Kubernetes, you've probably noticed that you end up dealing with a lot of YAML. But having YAML support directly in your IDE can make that a lot less painful. For example, if I'm looking at this Mongo deployment and say I want to know what the value is of this secret, instead of having to dig around in the YAML in my repo and figure out where that secret lives, I can actually just peek at it directly and see what the value is. And these base 64 encoded strings, I can just hover over them and see what the plain text values are.
I just want to emphasize, Christy did not choose that password. Christy would never do that.
Yeah, I'm going to have some words with some people after this, I think. So what I'm going to do now is open the configuration and make the change to 10 replicas. So now I would commit this, push it, and open a pull request, and then Cloud Build would kick in, and it would do all the things that we want to do to properly land this change in production. like running vulnerability scanning, tests, etc.
Thank you so much, Christy. And so this is what it would look like in Google Cloud Platform in Cloud Build, seeing the builds that have gone through into prod from version control. So once we've got everything working again, we're going to go back to sleep, hopefully, and get up in the morning and work out what the actual problem was in the app that was causing that performance degradation. We can use Stackdriver Profiler to do that. Stackdriver Profiler is really powerful. Some of our customers have seen double-digit reductions in CPU usage as a result of using it, and it's generally available as of Tuesday. So today, we showed you Cloud Code. Cloud Code lets you develop, deploy, and debug your Kubernetes-based applications directly from within your IDE. And it doesn't just work against GKE, it works against any Kubernetes cluster, whether that's local, in a data center, another cloud provider. Cloud Code will talk to any Kubernetes cluster. You can download the code that we've showed you today. It's available in Node, in Go, in Java, and in Python. Start playing with that right now. We really hope you're as excited as we are about this powerful functionality, and we cannot wait to see what you do with it. Thanks very much for your time. Back to you, Pali.
Thank you, Jess. That was super exciting to see, and one of the great ways you can increase developer productivity while you're building cloud-native Kubernetes applications. So let's talk about the next thing, which is shifting left. And the purpose of shifting left, as we discussed earlier, is to help connect all of that downstream feedback to your developers and your development teams so you can catch those costly errors much, much sooner. This could be everything from enforcing coding guidelines to getting operational metrics earlier in the cycle. And of course, one of the most important things you want to do is catch those security errors very, very early in the process, because those can be really costly. To tell you a little bit more about how we're thinking about shifting security left and give you a practitioner's view of it, I want to welcome Mike Berry from ANZ on stage.
So, good morning, everyone. My name is Mike, and yes, I work at a bank. The ANZ Bank has been operating in Australia for the past 180 years, and every day we look after the details and information of millions of customers, and we look after billions of dollars of transactions. So as you can imagine, security is very important to the way that we operate. Now, banking over those 180 years has changed considerably. It used to be about how secure your vault was and your branch, and that was security. But now we have more things to think about. In particular, today we're going to talk about security of our services and our applications as they're running in the cloud. Now, we have vulnerability scanning. So we're going to talk about two things. The first, vulnerability scanning. When you're running vulnerability scanning, the question is, how are you doing it? So today, do you have, in the audience here, do you have vulnerability scanning of some kind that you're running right now? Let's have our hands up. Yeah, we have. All right, we have vulnerability scanners out here. This is very good. My question is, when you run these scans, what do you do with them? Do you go, oh, I've got this scan run, and now I'm going to raise a ticket, or I've got this report, and I'll look into that, or raise a risk, or do these things last for a day, or for a few days? Or sometimes you're like, oh my goodness, we haven't run this for a few weeks, and now we're getting to the end of the project. Quick, run a scan, see how it goes. And then, oh my goodness, we're going to spend days going through these vulnerabilities, doing patching, doing retesting, doing refixes, and then finally, it's all sorted out. And so that kind of approach to your security can really slow down your work and impede your velocity. So what we're doing now at the ANZ is we're using the vulnerability scanner in Google Cloud, but we're using it in every build that we do. So we see here, we have our source code. Our source code moves into Cloud Build and does all the usual things we do in a build, but at the same time, we run that vulnerability scan. And what happens is, if that vulnerability scan fails, then instantly we have a red build, and a developer can go in, have a look at that, find out what is the issue, and it'll highlight for you the severity, it'll highlight for you which package is impacted by that, and you can go in and you can do the patching or remediation, whatever is required, and you fix that. So you find that problem, you fix that one small problem, and then that's resolved, run the build again, everything's green and everything's fine again. And so instead of taking this huge amount of pain down the end of weeks of your work and slowing down, we just take these little increments along the way. When we find these things as they occur, we fix them straight away, and that helps us keep that velocity moving as we're working in our development. And so that's one way that we're approaching security. The other one is binary authorization. So we've looked at kind of the left side and that CI process. Now we need to move on to the deployments. So as we move our deployments through, how are we doing the enforcement of this security? Because you may have lots of security applications, because that's the, when we scan things for vulnerabilities, that's one process we have, but we have lots of other security tools, lots of other test processes, maybe you have performance testing. How are you gathering that information and making sure that it applies to that binary that you're moving into your production environments? Because if you have security and you have lots of reports and you leave those reports stacked up in a big pile on your desk, that's not helping anyone. What you need to do with that information is enforce that. And so binary authorization is a way to enforce your security. Now, I will talk about it a little bit, but maybe what we'll do first is we'll do a little demo and have a look at how this applies. All right, there's no shortage of laptops today. All right, here we go. So, this is a simple demo. What we've got here is my 2 images in my container registry. And now by looking at those images, you tell me which one has passed all of my testing and all my criteria, and which one has not. And the answer is you can't tell, just so you know. But what we're going to find out. So what we're going to do is we're going to grab the business processor, and we're going to deploy it. Bam, one button, deploys. Yes. And we're going to hit refresh, and we're going to look at our cluster. And oh my goodness, that was the wrong one. So what we see here is that this has been forbidden by a policy that says this image has not been approved. And so the way this works, binary authorization sees your image comes in and it looks for an attachment that's attached to this. So it's a way to attach a certificate to say this has passed our policies and we have a certificate to prove that this image is okay with us. And in the case of this particular image, that image is not okay and it should not be deployed to our environment. Now, don't worry, we're not going to leave it with red. We're going to have a look at Business Orchestrator. That's our other image. I'm going to press a button, Orchestrator. I'm going to press that button. Magic's going to happen. Yes. Hit refresh. It's a perfect demo. So, green lights, everybody. We're all happy because this image actually has that certificate attached to it. Binary authorization reads it. It says this is past your policies. You are cleared all the way through, and you've got a big green light for that. And so the way it works is, imagine this, you have an internal audit team, and they come to you and they say, we need to understand your controls, we need to understand your policies, so what we're going to do with you is we're going to set you a meeting for a couple of hours, and we're going to read documentation together, and we're going to understand how your policies work. You're like, well, that sounds like a lot of fun, guys, but how about we do a demo? I've got an image here. This image has been approved by nobody. It's been tested by nobody, and really, I don't even know where it came from. And I'm going to deploy it to production. And then you jump into production, and you press the deploy button, and you show your audit team, look, this cannot be deployed to production. We don't just talk about security here, we enforce our security. And so we make sure these things can move through because they're approved. Now, when I've done this demo, I just did that with the one attester, the one policy, but you can have a multitude of policies that you may want to apply and do that for different clusters depending on how you've set up your organization. So imagine in one cluster, you're like, all that has to happen here is we need a peer review. That's all we need. You can deploy to this cluster. The production cluster, maybe you want a peer review, maybe you want to pass a certain phase of testing, and maybe you want to add to that that there's a team or even a person, if you choose to, that is a part of this. And so if we go back to the slides now, we can see on the left side, we have our vulnerability scanning, we're testing these things straight away, and then as they move through to deployments, we're making sure that we have just those trusted images that move through, and they're deployed to our engine. And because this is all a pipeline, so we have security, but it's moving through with automation and with the speed that we have available from this automated pipeline. And so at the ANZ Bank, that's how we're applying these two principles to make sure that we move with security and all the things that we need, but moving that security forward with speed and reliability. So thank you. Back to you, Polly.
So we talked about how we can increase developer productivity with Cloud Code. We then talked about shifting left, especially on security with Cloud Build. Now let's talk about how you can scale your operations. This is one of the huge benefits of cloud and why all of you are adopting cloud today. So as we think about scaled operations, my mind goes back to Google, because we've got 8 products with over 1 billion users each. And as you saw during the keynote yesterday, Urs shared a study that showed that of all of the major clouds, Google Cloud was the most reliable. And much of that is because we have internally in Google an amazing SRE team that helps us scale and operate all of these Google products and of course Google Cloud as well. And for the last 15 plus years, there's been one person at the head of that team. So I'd love to welcome on board Ben Traynor, who's been leading our SRE team for the last 15 years, for a fireside chat. Ben?
No pressure then.
So, Ben, we talked about all of these billion user services.
Yes.
I wonder how many folks in the audience are using billion user services every day.
Well, I suspect, probably a few, but it's one of those interesting myths. You say, well, SRE, isn't that for only the really, really, really big services? And I think we maybe have an opportunity to talk about that a bit, but certainly, I started the SRE team a little, as you say, 15 and a half years ago now. Google was not that big at that point, and in particular, some of the services that we were running were actually fairly modest in size. And we've found that we have a set of principles and practices that we can use across services at pretty much any scale, and we found that they helped.
Yeah. So Ben, as you think about these SRE practices, could you share a little bit more about what those are?
Yeah, absolutely. And I think you have a slide up here that talks about, a study that was it Forrester did recently about SRE practices and said essentially, can these be used by anybody, or do you need this huge monolith of code and engineering support? And they found that roughly half of them did not need this. But let me talk about a few of the SRE practices that I think are usable and applicable to pretty much anybody who's running a service. The first is one that we talked about a bit earlier, which is having SLOs. And SLO is a pretty dry term. It stands for service level objective. And the number of people who get excited about service level objectives is modest, let me assure you. But what SLOs really mean is you want to be able to measure what your actual end user experience is, and you want to have an opinion about what performance would be sufficient for most of your users to like your product. We actually internally call them happy SLOs. It sounds very cheery. But it's a very simple concept, right? Measure your application the way your end user sees it, and have an opinion about what the end user would need to see to be happy. Sounds really easy. It's actually usually fairly hard in practice. Most applications don't actually instrument what the user sees. They instrument some things that are along the way and say, well, good enough, right? And what we've found in SRE and in running Google services is actually that last mile of instrumenting the common activities that users are actually doing is really important. Oftentimes, the behavior that they see isn't what you think, and the instrumentation that you do on intermediate steps doesn't actually tell you about some of the problems that you've got. And so I like to differentiate and say, like, there's black box monitoring, and black box monitoring is what your happy SLOs eventually should be looking at. Now, as we saw earlier, if you're on call and the monitor says something's wrong, you want a little more information than that. And so in addition to that, you'll clearly have SLOs for internal microservices and SLOs for intermediate steps and so on. But the most important thing is instrumenting the end result, because after all, that's the only thing your user sees, and really it's the only thing that they care about. And that's something that you can do right away. In fact, really it's easier, trust me, to do when the application is small than when it gets bigger. So another concept that we use that really sort of applies to everyone is this concept of error budgets. And an error budget sounds like a very sort of odd thing. If you've read the SRE book, it probably seems less odd, but it's an important concept in site reliability, which is that our goal is actually not perfect availability. Because number one, right, your users are using a device, maybe a laptop, maybe a phone, maybe a computer, which is not 100% reliable. They're communicating with your service over a network, which is not 100% reliable, et cetera, et cetera, et cetera. And so the difference between, let's say, 5 nines and perfection is probably not distinguishable by your users, because there are so many other things that in the path that will also break their experience. But the engineering cost of the difference between 5 nines and perfect is immense, and its drag on your feature velocity is immense. And ultimately, you're running a business, you're running a service, and so these two basic goals, I want a service that's reliable, but I also want high feature velocity, I want to be able to launch new things that my users want, is really important. And error budgets is the concept that lets you bridge those two. And it's, it's really fairly simple. If your availability target is 4 nines, then your error budget is that last 0.01%. And you can spend it on silly errors, right? Pushes that shouldn't have been made, features that basically don't work, or you can spend it taking calculated risk, right? Exposing a new feature to 0.01% or 0.1% of your users for 10 minutes and measuring the result. And if you have happy SLOs, you know whether it worked or not. This lets you have very fast feature velocity because you can take a small risk, look at its effect on your SLO, and decide whether you want to make that a larger risk or not. And it also helps the SRE team or your operations team agree with your development team. Should we do this? Well, are we out of budget? Yes or no? If we are not out of budget, let's go ahead and launch it, right? We have budget to spare. And if we are out of budget, okay, data says we're not making sufficiently prudent or careful choices, we should hold back and spend a bit more time on availability. Blameless postmortems. Somebody mentioned it earlier when I think there was a hiccup in a demo. This is a necessary practice that's actually pretty easy for everyone to adopt, and it's not, not a complicated idea. Again, in theory, harder to implement in practice. But the basic idea here is you've hired good people. You have a recruiting process to identify people who are intelligent and smart, well-intentioned, and despite all of that, right, despite these people doing their best, something went wrong. Look at how your system works and figure out how you'll make it less likely for the system to break, easier for the people who are looking after it to fix it when it breaks, and make those the goals of a postmortem, right? Figure out how to make it more likely to succeed next time, despite the fact that there are going to be people working on this who are intelligent and well-intentioned and imperfect. And then finally, capping and eliminating toil. This is actually, it's better if you start this at a small scale, but this is the idea that every system, as time passes, requires more and more things that need to be done by hand because, we were in a rush, you needed to get that feature out the door, and there were a few bits that weren't fully buttoned down, but we can deal with them later. My experience is there is never the later, right? There's only the now, and by the time you finish that feature, there will be the next round of features that you're already slightly behind. So, get rid of that fantasy, and instead say, toil, human work to do something where that work does not make tomorrow better, you'll just have to do it again. Toil is another budget that you have to manage. And in SRE at Google, we say toil is capped at 50%. You can't have the team spending more than half of its time on sort of non-repeatable human actions to support various, interesting features and snowflakes and so on. And the rest of the time has to be spent making the service better, building production infrastructure, et cetera. And once you view it as a budget, then you ask the question, well, where am I going to spend my toil budget? And it'll be on the things that are brand new and hard, where you don't really know exactly how to do them automatically yet. And then you'll have a fraction of your development time that's spent implementing and deploying projects that get rid of toil in the places where it's now easier. And that cycle kind of continues forever. But it's important to keep this as an explicit budget, and it's important to actually watch to make sure your teams don't spend too much of their time on toil, because there's only two options, right? Option number one, your service is not successful, your business goes under, and none of this matters, right? Option two, your service is successful, it grows, and toil typically grows roughly linearly with the size of your business. So if your team is 50% occupied with toil right now and not doing anything to fix it, and your business doubles, guess what, right? You're going to be hiring a bunch more SREs. Not a good plan. So this is, in some ways, a plan for success, and it involves a certain amount of continuous investment, but it absolutely is the right path if you plan to be successful.
So Ben, as I talk to customers, the first thing they tell me is like, they love this concept, they want to implement all this, but they're worried it'll take them a lot of money, cost them a lot of money, or they probably need new people. So how do you respond to that?
First, I laugh. So, you know, as I tell people, I'm actually a software engineer, right? This is the first operationally oriented role I've had in my entire career. I started out in enterprise software, interestingly, at Oracle, when they were a little 400-person company. Who knew? And you don't actually need new people to do SRE or to do DevOps or to do these practices. In fact, you should have people who are engineers and who consider themselves software engineers and who will be bored to tears if you ask them to do the same thing over and over again, because they have the right mindset to say, how do I make a machine do all of this boring work, this repetitive work, this vigilance work that people are actually quite bad at, so that I can get on to doing something that's more interesting. And that's a great motivation. These practices then give them guidance on how to do that effectively. You definitely don't need new tooling. I mean, all of the things that we've described here, like what you have now in cloud is way better than what we had in SRE in the early days. And in fact, a number of the systems that we have here have been influenced by what people have discovered in DevOps over the years. And yes, this isn't just for cloud native, right? These same rules of physics essentially apply to any system. I will say that services that are running in the cloud definitely have it easier because, as you've just shown, you've built a bunch of the things into cloud that we had to build ourselves. But the open source community, if you're still running things in-house, the open source community now offers a lot of these systems for you as well, and I would definitely take advantage of them.
So as I talk to these customers, again, the other common thing I hear is, hey, we've already got a DevOps team.
Yep.
Right? So do we need to now create a second SRE team?
So the good news is no. I've gotten this question a few times over the years because I coined SRE back in 2004, and there was DevOps at that time as well, but both of them have emerged as industry, let's call them tracks since then. But SRE and DevOps are not different. SRE is a particular instantiation of DevOps, but nothing more. And if you actually go through and read what the different branches of DevOps have to say about how systems should be managed, how services should be monitored, et cetera, they're very similar to what SRE does. I simply would say SRE is a more specific implementation of this general class of DevOps. It's worked well for us. It doesn't necessarily have to be exactly the recipe that everyone follows. It's not the only path to success. But I would say these two are very much complementary ideas. And in some places, I expect the folks in the broader DevOps community absolutely will come up with a superior approach, in which case we will adopt it. And we have written now 2 books in the SRE team covering our specific implementation. And again, I think those are useful for folks to understand what we did and how we did it. They don't necessarily have to be adopted wholesale by other teams.
Yeah. So Ben, could you actually share with the audience what are like a few things that they could just start doing tomorrow?
Yes.
Right, to
Right,
adopt SRE.
So interestingly, when we wrote the first SRE book, that was one of the principal questions we got back is, okay, this all sounds great and these are interesting stories, but how do I turn this into practice? And so we wrote the second book in part to answer that question, and if you have the time and energy, I definitely recommend reading it. We put a fair bit into it. But let me give you 3 that you can do kind of today or immediately that are 3 of the most important practices, I think. The first is to actually write down those happy SLOs we talked about. It is perhaps unsurprising, but still surprising how few SLOs actually get defined and monitored, and how often what you find is what we've monitored is the thing that's convenient versus the thing the customer cares about. And then over a series of outages and postmortems, you eventually migrate. So you can skip that whole step, right, and go directly to sort of the great end result if you take the time to write down the SLOs that if you just barely were meeting those things, most of your customers would be happy. And then dog food them, right? If you use your product internally, and you should, try making your internal instance of your service operate where it's just barely meeting those SLOs you just wrote, and see whether your internal users are happy. And if everyone's more or less, yeah, you know, seems slightly sluggish, but it's okay, you've got a good SLO. If everyone grabs their torches and pitchforks and comes to your door, you may want to revise, right? Secondly, we talked about toil. Toil it's like technical debt, right? Except it's much easier to measure. And my recommendation is, you know, look at your sources of toil and just pick the one that's the highest ROI, right? It's easy to fix. It occupies a lot of people's time, maybe because it gets done a lot. And start an engineering project to actually fix that, carve out folks' time. Because it gives you this great experience of now we've spent N months of engineering and we've gotten rid of N years per year of toil. Okay, now I see how the system works, and we can have a regular review and sort of look for our toil and decide which ones are worth eliminating. And that gets you started on a path to avoid what we call ops overload, which you don't want to be in. And then finally, everyone has some production incident, right? Whether it was an actual full-blown outage or just something that didn't go well. Conduct a blameless postmortem. Try the approach of saying, let me assume that although humans will always make mistakes, I'm not going to focus on that because I don't actually know how to fix that in the real world, but I can fix how the system works. And conduct a postmortem where the conclusions are we should fix the following things in the system to make it less likely to fail, more likely to provide good diagnostic information when it does fail, make the failure less severe, make the failure shorter, and see if you like that result, because my prediction is you will.
It's awesome. Thank you, Ben. So we have a few more minutes, so I thought it'd be good to give all of you an opportunity to ask some questions to Ben on SRE and DevOps.
thanks everyone for joining. So, wanted to start off today's talk just by talking a little bit about why we moved to cloud in the first place. So, we're trying to get on cloud because we want something that is fully flexible, fully managed by someone else, where we still get all the latest technology and a fully reliable service. But I think what's core to that is that there still needs to be some group of trusted people who are there delivering the service to you, who are there operating the service. What we're showing here is some very productive Google engineers, having a chat one day. And this is going on every day at Google. These people are writing the software that's running the data center. They're restarting the machines if there's something wrong. And they're the ones who are really responsible for making sure that you get the service that you know and love the best. So core to that is really this trust equation, which is always going through your mind, which is, am I secure in the cloud? Can I trust these people who are working to secure my cloud? Is my privacy being protected? Are these people just accessing my information without my knowledge? And is my service available when I need it? Are these people actually doing the job of keeping this service up and running and giving me the service that I'm paying for? And these things are all in a delicate balance with one another. We don't want to give our engineers, unlimited privileges so that they can just go and fix any error at any time really, really quickly. But also, we don't want to make life impossible and lock all access down to the point where, you yourself go to click on your information and it says data unavailable because it's locked down. And so, what we want to talk about today is what we see as the foundation of addressing these needs. And really, it's built on three things: great technology, world-class operations, and full accountability. And at Google, we see the cloud provider as needing to take the lead on the technology and operations side. You need to trust us with the technology and operations and make sure that we're doing the right thing. Because otherwise, what's the point of being on cloud? If you have to constantly manage what we're doing, you may as well have your own data center. But on the accountability side, this is where you come into the equation. We want to give you transparency over what's happening, what's happening with my data, how can I control it in certain cases where I have, special needs. And we're going to talk to you a little bit about some sort of exciting products we've released at Next, as well as the products we've been working on over the last few years, later on in this presentation. And so I'm now going to hand over to Ollie. He's the software engineering lead for access transparency and access approval. And he's going to talk a little bit more about the technology and operations side.
Thank you, Joe. So I'm going to start by talking about the technology that Google employs to ensure that we're able to provide the security, privacy, and reliability needs that our customers have. Now, compute infrastructure faces risks at all levels of the technology stack. And so consequently, Google has adopted an end-to-end security story that extends all the way from the low-level hardware all the way up to the applications that ultimately touch and process your data. I'm going to talk through each of these layers. Let's begin with the hardware. Now, most consumers, when you purchase a device from your hardware vendor, you assume that that device comes to you in the pristine state that the manufacturer intended. However, at Google, supply chain attacks are a very real concern. We need to have strong guarantees that that hardware has not been tampered with in transit. And so we've developed Titan, which is a crypto processor responsible for verifying the integrity of our hardware. Before the first instruction is executed on that machine, the Titan processor verifies that the firmware on that device has not been tampered with. And that allows us to enable a hardware root of trust upon which all of our other security controls can be built. Now, Google has a large number of machines, and they exist in a variety of states. We have different versions of hardware, different versions of software, machines that are in maintenance, machines that are actively running, machines that are in the process of being booted. And so we needed to have a scalable way of ensuring that every machine in our fleet comes to a known secure state before we're able to run production workloads on those machines. And so let's look at the boot process. This is a typical machine boot process. You power on the device. The BIOS is loaded from firmware. It executes, does some initial configuration, loads the bootloader, which in turn loads the kernel, which ultimately mounts the OS image containing most of the software running on that machine. Now, engineers at Google have worked to harden each level of this layer of this boot process. We've removed unnecessary code. We've identified and fixed security vulnerabilities. In many cases, we've contributed security vulnerabilities in the Linux, we've contributed security fixes in the Linux kernel directly to the upstream community. Furthermore, now that we've established a hardware root of trust with Titan, we can use each layer of this boot hierarchy to verify the next layer. So Titan verifies the firmware, the BIOS, which in turn verifies the bootloader, which in turn verifies the kernel, which in turn verifies the OS image. And in doing this, we develop a cryptographic chain which can be verified and validated to ensure that once we've completed our boot process, that machine has entered a known, secure baseline state. Only then can production workloads be put on that machine. Now, in reality, machines don't exist in isolation. They interact with other machines across the network. They interact with services. They interact with humans. And so each of these identities on the network is given a cryptographically secure identity. We need to have trust that a machine is the machine it says it is, and that it has not been compromised in some way. So we just saw the process via which machines boot up, from the hardware through the boot process that ultimately generates a cryptographically secure chain of trust. That needs to be validated before that machine can take on an identity. And only after the machine has taken on an identity can it interoperate with other services on the network. The same holds true for our service identities and for our people identities. And we'll talk a little bit about the requirements for each of those a little later. Now let's talk about storage. All communication in Google's cloud platform to it and within it is encrypted via TLS. Once your data is uploaded to the cloud and subsequently written to storage, that data is split into chunks. Each chunk is secured with a unique encryption key. And those keys are stored in our highly secure key management service. It's worth noting that only services that have a valid need to access that data are allowed to download those keys. So for example, the Google Cloud Storage, the binaries that run the Google Cloud Storage system can only download keys associated with Google Cloud Storage data. They can't get access. They cannot decrypt data belonging to Cloud Bigtable or any other service at Google. Now, last year, we launched a service called Binary Authorization. And this is designed to provide strong guarantees around the integrity of the binaries running in your production systems. Binary authorization ensures that only images that have gone through your organization's internal build and vetting process can be deployed to Kubernetes Engine. Google has its own internal version of binary authorization. And this provides strong guarantees that all code deployed to production has been checked into long-term source control. It's been reviewed according to Google's internal processes. And it's been built in a verifiable, repeatable fashion so that we can go back. We know exactly what source code went into that. We understand exactly what build parameters went into that. Only once all of these requirements have been met can that code be deployed to a production. And only then does it obtain an identity that allows it to interact with other services on the network. And it's worth noting that the identity does not grant broad access. As we mentioned earlier, we have fine-grained access controls that ensure that service can only access the data that is necessary to run that service. All right, now, contrary to what you may have heard in the news, the great AI awakening has in fact not yet happened. We still employ people. And so I want to talk through some of the safeguards we have in our operational controls to protect you and your data from insider threats. Let's start with the data centers. Ultimately, this is where your data resides. And so Google takes the security, the physical security of our data centers very seriously. We have fingerprint scanners. We have optical retina scanners. We have laser beams. I joked internally, asking when we were going to get sharks, and they informed me that in North Carolina we do in fact have alligators. Once a Google employee has gained access to a data center, their ability to move within the data center is still restricted. Google employees are only able to access locations for which they have a valid business need to be there, and they need to badge into each new location that they enter. Those badging events are logged, and we have auditing after the fact. We also have a number of safeguards in place to protect our employees on the network from being compromised. All employees have to use a phishing-resistant hardware authentication token. These are the standard USB fobs that you're aware of, and you can actually purchase these for use by your own employees if you're using our cloud platform. We also require all access to go through a device which is managed by Google. I, as a Googler, cannot log into Google, cannot communicate on the network from my personal machine. I have to go through a device that's managed and maintained by Google. And only after these two conditions are met do I obtain a cryptographic identity that allows me to interact with services on our network. We've also engineered security and privacy best practices directly into our operations process. Each individual at Google has a role, and there's certain access that they need in order to perform their job responsibilities, but they are restricted to fine-grained access controls ensure that they only have the access needed to perform their job responsibilities. All of our support tools, when you call Google, when you log a support request, you need help with a problem. The support engineer cannot access your data without providing the support ticket associated with that call so that we have a clear record and a clear understanding of what that access is for. And all accesses to user data are logged and audited internally. We also take measures to reduce the need to touch user data at all. Many of our common support and maintenance operations are automated. They're hidden behind access-controlled APIs so that an engineer rarely has a need to SSH into a VM to help you debug a problem. Most of the common tasks can be automated without requiring that level of access. Similarly, many of our internal dashboards strip away user content. They use internally identified unique IDs rather than the names that you assign to your projects and your VMs, so that no personally identifiable information is conveyed via these dashboards. All right, now I'm going to hand things back to Joe, who's going to talk about some of the technology that allows you to hold us accountable.
Awesome. Thanks, Ollie. So we've heard a little bit about the technology and the operations, this chain of trust that stretches all the way down to the hardware, all the way up to the way services gain identities, the way people gain identities, and the way that our operations are run is really built on top of all of that. And so our focus for the last few years has really been on surfacing all of this chain of trust to you in a way that allows you to make decisions about how you want us to use your data. We've had this phenomenal set of internal visibility and controls, and while you, in the past, have sort of had to put your data on the cloud and just sort of trust the cloud provider, we're now making all of this available to you through access transparency and access approval. Access transparency has been available for a number of GCP services stretching back to last year. And we're excited to announce that there's a number of new services that join access transparency this year in both GA, beta, and alpha. And I'll speak to a little bit more on the next few slides. Access transparency gives you the near real-time logs of these administrative accesses to your data. As Ollie was talking about before, each of these support tools, even when we stretch all the way down to an engineering level access that's made from a command line tool, is collecting and validating a business justification. We're taking that justification up and surfacing it to you so that you can check it against your own processes. And I'll go into this a bit more detail in a second. Access approval is a new product that allows you to pre-approve those accesses where eligible. And what that's going to do is require that Google employee, even if they're very highly privileged, to request access from you beforehand before they're even able to see any information at all. So let's look at an example of how this works in practice. I want you to imagine that it's late at night, you're trying to fetch a file frantically off Google Cloud Storage, and lo and behold, something seems to be wrong with it. It looks like it's corrupted. You need to call Google Cloud Support to get it fixed. Now, things that you do on GCP and that your employees do on GCP are audited by cloud audit logs, and you get a clear record of what happened. You attempted to access your bucket, you tried to read this object. So you telephone Google support. Google's frontline support teams have very heavily restricted access to data. They cannot see what's inside your bucket. But what they can see is certain things like the bucket access control list. Now, in many cases, people refer to these pieces of data as metadata. At Google, we just include all data that you give us as your data. We don't make value judgments about sensitivity levels or anything like that. We will, if you give us it, we will track it, we will log it, we will apply our access controls to it, and we will surface the accesses to you through access transparency and bring them into scope for access approval. Now, even though all the support technician is trying to do is see who has access to that bucket, with access approval on, they're going to get access denied. It's not until you actually approve that access that they can go ahead and read that access control list, at which point they generate an access transparency log. So you now have an end-to-end flow showing what got touched, why it was touched, when it was touched, and by whom. Now, let's say that there's still an issue. You know, everything seems fine, you have access to the resource, there's no reason why this problem should be happening. We need to go ahead and escalate to Google engineering. Now, this is going to go to one of the engineers on the Google Cloud Storage team. These are the people who actually built the service. They're responsible for maintaining it. There is a serious issue. We need to get this resolved. Now, even on these, like I said, even on these lower level engineering tools, again, we're getting that ticket coming through. We're getting this access denial process, and they're having to request access from you, a customer, before you're able to access the data. I will stress that outage and legal access are excluded at this point. That's just to stop situations where we have a multi-user affecting fault and everything's on fire and we may need to go ahead and do something. Got very strict processes around those. But for the large part, you'll be approving that access and we generate an access transparency log of that information as well. So you can turn this on. Access transparency requires that you have platinum or gold support or equivalent, and access approval requires platinum or enterprise support. Access transparency can be enabled today on the GCP website, but you should contact sales or support for access approval information. Now, for the vast majority of customers, really, the Google managed access controls that we've been talking about for much of this presentation, plus maybe some additional transparency through access transparency, are going to be 100% sufficient for your use cases. Access approval is a very heavy-duty control. It enables you to fully manage the access to your data, and it's suitable for cases where you might have really highly sensitive information, but for the large part, you probably want just the flexibility of being able to call up support and have them address your issue immediately. So what's it available for? We're excited to announce Access Approval Beta is enabled for 10 services. So there's the full list here. It's so long I won't even read them anymore now. So Access Transparency Beta is also enabled now for GKE, Spanner, and Dataproc, which we're very excited to announce. And we've also got another 6 services entering Alpha 2. You can read more about this on our website, so I can probably jump to the next slide. Now, as we've spoken about, while you may hear from other cloud providers that there's sufficient tooling in place that covers the support level, what I really want to stress is that we have coverage not just over the support custom tooling, but also the engineering internal application APIs, as well as general purpose storage systems that may be accessed by engineering. This is going to give you visibility and control all the way down the stack to the deeper control paths where you have someone who is highly privileged who is accessing information. I'm now just going to give a quick video demonstration of how something like this might work. Now, I'd love to do this live, but it involves people who are on call and highly privileged, so it's much smoother to pre-record. But we're just going to jump in and show this demo now. Just blow this up so everyone can see it. There we go. So imagine you're browsing Google Cloud Storage, you get some error that you're getting permission denied on Cloud KMS key, and you can't figure out what's going on. So you're going to click that support button, send a support ticket, and here's what the support technician will see. They're going to need to enter a justification in order to access your data. Now, this is a simulation because obviously we can't show you our internal tooling. But what I want you to note is that there's a case number that's being entered there, and that individual case number is being programmatically validated. So 1, 2, 3 are the last 3 digits of that case number. Just keep an eye on it because you're going to see it a lot more throughout this presentation. So they're going to go and attempt to access that information, but before they're able to do that, you'll need to approve it through access approval. So what you're seeing now is you can clearly see the resource that's being accessed, when it was requested, how long the access is needed for, the country of the accessor, and there you go. It's the case reason that we opened up before, the same reason number. So we have this already, starting this chain of end-to-end visibility. Let's go and approve that access. Now, in the background, support are going to go ahead and work out your issue for you. Let's get that resolved. You're going to go back, try and access that file again, and voila, it works. You can download the file. I don't know why you would store the Google logo on your GCS bucket, but let's just say you have. We're going to now jump into Stack Driver Logging. In Stack Driver Logging, you can pull up now the access transparency logs. You can see exactly what this support person did, when they did it. We can see, this is how you know this is real because we include the loading screens as well. We can see here all of the accesses that were made. Really, it's just someone who was trying to see which buckets I had in my Google Cloud Storage system. And there again is my case number, so I can see 202.123. This all looks fine to me. It's a pretty benign operation, and I have the full audit trail. I also get the audit logs of people who inside my organization who approved any access. So I can use that to get a full audit trail going all the way back. So let's dive into a little bit more detail. What do you get? You get at the top of every access transparency log the location and sort of entity information about who and where your data was accessed from. And then you also get some information about exactly what happened. So in this case, I can see that it's just the access control list of the bucket that's being looked at. It seems pretty benign to me. It's all good. And then again, like I said, you get both the reason type and the reason detail. So all that end-to-end auditability is there. For access transparency, we include all non-outage human access for support, and it's included in access approval as well. Now, outage accesses, you'll get the access transparency log, but like I said before, there may be certain cases where we need to hit that big red button and go ahead and bypass access approval. You'll still get a log of that information if that were to happen. Legal accesses, this is a bit of a tricky area. You get these unless we're prohibited by law from surfacing them in access transparency. However, they're not included in access approval. System access, these are those things that Ollie was talking about before. You know, the binary goes to access the information. We've got that binary authorization control in place. So showing you how our transparency really builds on that chain of trust that we established earlier in this presentation. Because of that binary authorization control, we exclude the system access from access transparency and access approval, and that just allows the software to go ahead and run and do exactly what you expect it to do without you needing to intervene. Underlying storage access is included in access transparency, but it's still coming soon to access approval, so stay tuned for more updates there. So we've covered today in depth how you get the full transparency, and now you get these new controls that stretch all the way up from the lower level systems to the higher level access. And we've also covered how our chain of controls from our hardware all the way up to the application layer and through our operations is reflected in what you see in these access transparency logs and how you use access approval. But for those of you who need more information, we've got some detailed tech white papers. I encourage you to search for our encryption, data deletion, and security white papers. We have more coming out very shortly that will talk a lot more about the details we've covered in this slide. We also have compliance certifications that audit many of the controls that we've spoken about in today's presentation, as well as our annual transparency report that looks at government access, if that's of particular interest to you. There's a website you can go to find out more information, but now I'm going to open up the mic if there's any questions. Hello.
Hey, thank you for the presentation. If I choose to dismiss, do I get an opportunity to provide feedback as to why?
We don't have that at the moment. The reason being that we have the support ticket, and so you can just leave some information in there and it will go in. But we're going to add some nice hooks in soon so that you don't have to switch screens. Yeah.
Okay, thank you.
No worries.
This is really cool stuff, and I love the transparency and access controls.
Thank you.
Where do customer-supplied encryption keys fit? Like, I feel like I almost don't need them, but maybe I shouldn't say that.
Yeah, I mean, we should probably, I think I've got I thought the encryption question would come up, so I brought the encryption guys with me today. We should maybe sync up afterwards and talk a little bit about how they fit in detail. But I think the core of it is that, just with encryption alone, we don't solve the entire problem. We still need to have access controls in place so that people aren't doing things like hijacking a service account and using that to access your data. And then you think, oh, great, this is just a service account access, when in reality, it's a manual access that someone's doing to perform some maintenance. And so really, these controls are additive and give you that extra layer of transparency, but also interplay nicely with all of the encryption options that you're using as well. So we can definitely talk more about that.
Cool.
After
Thanks.
the show with these folks. Thank you.
Hi, great presentation. Thank you.
Thank you.
From an access approvals perspective, things make sense because the customer is always involved. So, someone is approving and you get to check that because you always know about it. But from an access transparency perspective, yes, it's great that that information is there in Stackdriver.
Yep.
But, we use like Splunk for our infrastructure in terms of figuring out what went where and, in terms of getting there and writing triggers and everything. So how do I get these logs across into my Splunk infrastructure?
Yeah, absolutely. So the access transparency logs get sent straight to Stackdriver logging. So any existing exports you have that will pull all of your logs out of Stackdriver logging will work the same. And then there's just a unique sort of identifier that you can use if you want to do a really narrow export out of Stackdriver. And you can export that straight out to Splunk. So and there's some information in our documentation, but I can send you some stuff as well if that's helpful.
Okay, that's great. Thank you.
Great, thank you.
Hey, it was a great presentation. Right up until the point you said, unless not required by law.
Yes.
So obviously there's a mechanism that you have to take those required by law logs out of your stuff.
Right.
So how can we be assured that that mechanism is being used just for the law, and as well, non-American companies, how can we make sure that our data isn't being accessed by the American government in a way that we don't like?
Yeah, absolutely. So, very tricky question. Obviously, right up front, you know, the first thing we have to do is comply with the law. It's unfortunate, but you know, none of us want to go and spend. Not that there's anything wrong with Hazleton, West Virginia, but you know, you don't want to be in prison there for a while. But I think the other thing is, first of all, we have a very, very strict process by which we serve these requests. So we don't have like, as Thomas mentioned actually yesterday, we don't have like a backdoor that we just have it open and governments can just go and get whatever. We take each individual request. We have like, you know, a whole team basically of lawyers who are responsible for making a judgment call about, you know, are we going to litigate this? Like, is this legitimate? You know, is this too broad? And once they make that judgment call, it's actually that team of lawyers who make the assessment and have control of the tooling around, around whether or not this is going to show up in your logs. So it's not, there's no like, the GCS engineer who's in the GCS team and is like, oh, I want to, you know, I'm super evil and I want to exfiltrate all this company's data and I don't want anyone to know about it. They don't just have like a switch that they can flick on. And that's really the control that we have in place. I can talk a little bit more probably in detail about like exactly how that works if it's of like super interest to you, but yeah,
Okay.
That's the high level of it, I think.
Yeah, I mean, my company doesn't have that type of data, but I'm guessing that if I did have that, I would bring my own keys.
Yeah, and this is the key management option as well if you need additional controls, and then,
Great, thanks.
Thank you.
This is really great content. So is there anything on the roadmap to bring this capability to internal users so we can really get that privileged access management, just-in-time access? You know, because that's really the capability that you know, that really ties out a lot of our industry compliance requirements.
Absolutely.
Is that request, review, approval process in console, right?
Yes.
In the cloud management layer.
Yeah, and the reason I just looked at Ollie was we've been standing at the booth talking about access transparency, and this is like the most frequently requested thing that we've probably heard throughout the conference. So, you know, definitely really want to absolutely bring it to you guys. Don't have a committed date around it yet, but by all means, if you want to, you know, give me your information when we're sort of ready to talk more about dates, I'm more than happy to reach out and let you know.
Sounds good. Thanks.
Thank you.
So if you deny or if you don't approve the access control, what's the workflow from that point on with the open service ticket?
Yeah, so I mean, if you deny the access, at that point support are just going to say to you, you know, what do you want us to do? Like if you're down in production and we can't help you and we can't see anything, because like I said, it's quite heavy duty, so you get protection over all your data, including things like, you know, your access control list or just the names of the individual services you might be running. If you say, look, it's fine, I'm happy to just go ahead and sit this one out, then the ticket probably gets closed. If you continue to say there's an error and I denied this because I want, you know, you to request not access to my project but access just to this one particular resource, then our support people will basically just go ahead and request that narrow access, and hopefully you can approve it then and get the comfort you need to get some help.
Yeah, it's kind of adding to that. I mean, it's worth calling out. Yes, you can have a conversation with the support agent. I know Joe highlighted that there's country information associated with the access request. That's actually included as part of the restriction on what you are requesting access for, or what you are granting access for. And so I know a lot of companies in Europe, for example, are somewhat distrustful of the United States, or they might be worried about geographic boundaries. There is an opportunity to say, you know, look, I'm not comfortable with this access from a specific geolocation. Can you request it from someplace else? And we have that facility built into the product so that you can get, kind of the granularity you want. Now, the trade-off here is, while you're having a conversation, you have an issue that you need to get resolved. And so you need to figure out, what the right prioritization is there.
Yeah. Hi, great presentation. 2 questions, actually, if you don't mind.
Yeah,
the first is for access transparency. Is there some kind of a notification mechanism in there to let administrators know that there's actually something to approve, right? Because you don't always get the support response right away.
Yep.
The second question is, can you actually provide an example of when you may have to obfuscate your access, right, for legal reasons?
Yeah, sure. So on the first question, we have email and PubSub notifications built into access approval. So you can wire those up in any way you like. If you're comfortable just using email, you can just put it can be a group, it can be a list of individuals inside that email list, and we'll go ahead and email all of them every time a new access approval request is opened up. If you want to go down the PubSub path, obviously that's great as well. You can hook that up to some external control center that you might have and have the notification surface there as well. On the legal question, I think an example would be, so let's say that there was a child safety incident and the government issued, often many of those cases have a gag order in place, and they issued Google with a warrant, and they were like, there is an employee at company X who, has blah information that they're storing on some Google service. We would definitely push back very, very hard and say, hey, you should be going to company X and not to us. But there's always a possibility that, we lose some court battle, and then this information is subject to a gag order and we just can't share it with you. And so that's probably an example of how it could happen. I do want to stress, though, I think there's been a very extremely minute number of these kinds of things happen in the past, but it exists because it is possible.
And we do also have a transparency report. And so if you're curious in getting more information about how frequent those sorts of accesses are, the answer is they're very infrequent, especially for enterprise customers.
Yep.
But you can go look at our transparency report for more information. I also want to stress that in addition to the PubSub feed, we also have an API for approving requests. And so if you are a large, sophisticated organization where maybe you want to route approvals based on product area, or you want to have finer grain control, maybe there's a class of approvals that you're willing to pre-approve via, maybe you've used our AI technology in order to build a screening app for things that you might care about. You can kind of have those systems do automated approval or route as appropriate.
Cool. Any other questions? No other questions? Great. All right. Thank you, everyone, for joining us. Hope you enjoyed the presentation. Your feedback is much appreciated, so please let us know through the mobile app. And enjoy the rest of the conference.
Hi, I'm Samrat Ray, and today I'm going to talk to you about how do you effectively prevent data exfiltration on Google Cloud Platform. So we'll talk about the various data exfiltration risks that pertain to public cloud platforms, and we'll talk about a methodical approach to thinking about those risks, and then we'll look at some of the controls that are available on Google Cloud Platform, and in particularly, we will focus on what do we do about multi-tenant public cloud services, right? And how do we control for exfiltration while we're able to still use things that make public cloud so powerful. A little bit about me. I'm a product manager for Google's security and privacy organization. Right? I primarily focus on service security and insider risk. I'm a product manager for one of the products that we'll go into depth in this session. So before we start, we're talking about mitigating data exfiltration risks. Let's start with how do we define data exfiltration? Data exfiltration can be thought of as the unauthorized copying or transfer or access, right, of data from a source, right? It's very important to think about it as not just access, but a key verb over there is the copying and transfer of data. Those are key elements that you need to think about when you think of data exfiltration. So to expand that to a more technical level, right, what are the risks that you actually need to mitigate as part of your data exfiltration strategy, right? Think of the kind of risks that you can have. These are risks that can occur irrespective of a public cloud or not. So these are a generalized listing of risks. The first is you can have misconfigured access control policies. So in many cases, your access control is delegated to a large number of people. Sometimes you have fragmented systems that do access control. So you can have access control misconfigured policies either on the back end or on the client, which then overexposes the data to a larger number of people than who are not actually authorized to see the data. And this could include, for example, in the worst case scenario, making it accessible to everyone on the internet. The second is, even if you've got your access control policies correct and pinned down, a lot of web access today occurs through the use of identity tokens, right? Like your OAuth or JSON Web Tokens, also called JWT, right? And other forms of credentials, right? Like API keys, for example, right? All of these credentials can be stolen, right? Or be copied, right? From where they were secured. And then that can be then used to access data from an unauthorized client, right? So thus transferring or copying of data out of where you want it to be. The third and the fourth are sort of slightly different versions of effectively the same risk, which is the first two correspond to preventing access from unauthorized sources to some extent, right? The third and the fourth are actually harder to mitigate because in this particular scenario, you have either a malicious insider as a human or compromised code, which could be again, deployed by the human, the malicious insider, for example, or could be compromised in some other way, right? Effectively copying data to unauthorized destination. In the third and the fourth cases, the data is being accessed from an authorized client, from an authorized source, using an appropriate credential, right? So trying to protect access to the source does not help mitigate the risk for the third and fourth. You actually need to have a way to constrain the movement of data effectively. So let's now talk about what is a sort of a structured approach that you can take towards mitigating data exfiltration. The first thing to note is data exfiltration is an exercise in risk mitigation, right? You never can eliminate things like somebody taking a notepad, writing something down and walking over, right? That's a whole different form of security that we'll be talking about here. In the context of software controls, it's about mitigating risk. And the primary risk that you would want to mitigate typically is broad access to data and broad copying of data across two unauthorized destinations, right? And as with any other risk mitigation exercise, our recommendation is that you think of data exfiltration, the controls associated with to mitigate these risks, to be a pervasive defense in depth approach, right? You need to have multiple controls in place to give you the most effective security against data exfiltration. So what are the control points, if you think about it from a very structured manner? What are the control points and the kind of controls that you would want over there? So the 3 places where you can place controls, right? At the source, at the client, right? And at the perimeter, right? Or the network edge, as you might call it. So at the source, clearly you can have access control on the source. And some of the risks, the way to mitigate risk there is to have implement the principle of least privilege, which is make sure that only those who are authorized to access the data have access to it, including programmatic clients as well, right? Make sure they can only access what they need to access, and whether they need to read or write, it's exactly those permissions that are granted to such clients. The second is ensure that access is granted on multiple factors. This is particularly important if you're granting access from the internet. You want to ensure that you don't just grant access based upon a single credential, but you have additional factors to further strengthen your sort of authentication before you grant access. Then again, at the source, you may want to ensure that the configuration is locked down of your resource so that you have central policies that can help you lock it down so that any delegated fine-grained permissions, if they have been misconfigured, that you can mitigate the risks. About the clients, you can do things like we have a tool called binary authorization, which allows you to determine that any code that is deployed on a client comes from an appropriate provenance, has been signed by the right authorized users. So you can ensure that only authorized code can run on the clients. You can do monitoring, so you can identify anomalous behavior of the client, right? And you can signal based upon that. You can decide to only grant access to things from devices that are well managed and are locked down, right? So those are the kind of things that you can do at the client level. At the network level, this is the classic approach that we have all been doing for many years, which is to have a well-managed and secured perimeter. So you can have ingress and egress sort of policies. Think of them as like firewall policies that you would have. So but very interestingly, we can provide tools to ensure that it's not just about your layer 3 entities that define the policies. You can have layer 7 entities. So for example, you can say which identities are authorized to access from which networks and from which clients as part of your ingress policies. Similarly, on the egress control, you can say what are authorized destination, irrespective of the identity that is being used to egress. This is very important. Like on the ingress side, we talk about the identity and the use of identity to sort of narrow down who you grant access to outside a perimeter. On the egress side, it's very important because of the kind of risks and the threat model that we talked about, is that you are actually egressing with a legitimate credential, right? So you want to actually have controls that are independent of the identity on the egress side. Now, having said all of these, right, and the defense in depth approach, I think it is important to understand that perimeter security for these particular risk pattern is a mandatory control, right? You can build the other defense in depth pieces, so we'll delve a lot more into how do you build effective perimeter security on a public cloud platform. So why is it mandatory? Why are the other controls not sufficient, right? Your source controls, which we talked about, address only ingress. Compromised clients or users with authorized credentials can still exfiltrate data, no matter how well you protect the source. There are legitimate reasons in many business scenarios, like to actually copy the data, right? You create a BigQuery materialized view from a GCS data source. That's a really legitimate use of why you would want to copy the data, and you don't want to prevent that from happening, right? Not all clients can be binary authorized, right? This is pertaining very specifically to containerized clients, which you can have immutable infrastructure around, and so on and so forth, right? Monitoring is after the fact. So if somebody can do bulk copying, monitoring does not help much. It helps if they're doing ongoing copying, you can prevent it, right, from further damage. But if they're just done a bulk copy, it's not very useful. The other area where there's some misperception out there, which I feel is like the role of BeyondCorp in this posture. So BeyondCorp effectively is an ingress policy. It's a layer 7 ingress control that offers finer grained control based upon who is the user. Are they coming from a managed device? Are they coming from the right network location, right? So it gives you and which endpoint and path and data are they trying to access, right? Which are all layer 7 sort of entities, right? This is a much stronger security guarantee than a classic layer 3 VPN, where all you do is check, oh, they have an RFC 1918 address, the client, and therefore I shall now not look at any other factor and just grant access based upon a credential, right? So it gives you stronger security on the ingress path. But it is not a substitute for a well-managed perimeter, right? You still need to control for egress, and you still need to control for clients that don't necessarily fit into your BeyondCorp model all the time, right? Like your compute instances or some VMs that might be running some arbitrary software inside your network. So that's a generalized posture. I would like to drill down, given this is a vast topic and we can't go into depth into every one of these dimensions. I'd like to drill down on the concept of what you need to do about multi-tenant cloud services. Because these are things that, services that you have now started adopting as part of your cloud adoption. And they have a different threat model, right? And they present new risks, not all of which has been sort of thought through completely as you try and adopt cloud, right? A fundamental change in posture that you have as you move from on-prem to cloud is that your data on-prem, the broad access to data, was typically behind one or more firewalls, right? So you would narrow down the access to data using application logic, and maybe that's what you expose as an API or an endpoint or a web endpoint that's accessible from less secure network places, right? But broad access to data, the back end of your databases typically, was protected by one or more firewalls. As you move to cloud, you want to put your data in these powerful storage systems that, say, for example, Google Cloud offers, like storage or Google Cloud Storage or BigQuery. However, these systems now offer broad access to data, and they're accessible from the internet. So it's a very fundamental change in posture, right? Secondly, these services are multi-tenant, as in not every resource associated with the storage system is under your control or is managed by you. And that presents new risks. So let's look at some of what is the risk posture, or what are the risk models over here for multi-tenant services. So we talked about oversharing using IAM policies. That is consistent and not a new thing that is specific to multi-tenant services. The same thing about stolen identities, right? Again, it's not specific to multi-tenant services. But what's new here, really, is how data can be exfiltrated by a malicious insider or a compromised code. Because your typical firewall policies with egress policies, all you can say is that grant access to the Google APIs, or not grant access to the Google APIs. Once you grant access to the Google APIs using your egress policies, at that point, a given client can pretty much copy data to any resource, assuming that they have the appropriate read authority on the source, right? And your firewall policies actually do not prevent that. So any entity, whether from the internet or from within your network, if they have the right credential, can now copy data over to an unauthorized resource, either of the same service, right, or of a different service. So, and there are two paths through which they can move data. One is they can download the data to the client or the compute instance and then write it to a public endpoint, right, as an example. And there's no real credential checks, no identity checks that matter, right? The second thing is they can use the backend or service-to-service paths to write data between the two. So in this particular case, you're showing from one cloud storage bucket to another, right? And none of these paths are covered by your firewalls today. So these are new risks that are presented by multi-tenant cloud services. So the big question is, what can you do and what can we do together to help mitigate these risks? So this is the threat model that we had in mind when we introduced VPC service controls. So VPC service control is a policy to segment resources of multi-tenant GCP services in order for you to mitigate data exfiltration risks, right? And so effectively, by using VPC service controls, you can start leveraging these powerful multi-tenant services and our data processing capabilities while still retaining the security that you associate with a VPC or your private cloud, right? So if you think of a service, a multi-tenant service, there are 3 network paths associated with the service. And we have shown all the 3 here. The 3 are the network path from the internet to the resource, right? From your private network to the resource, right? That's the second path from your VPC network. And the third is between resources on the back end of the services themselves, right? So for example, BigQuery accessing the Google Cloud Storage to create a materialized view, or copying of data between 2 storage buckets, for example, represent the last pattern, right? And so each of these paths need to be controlled, right? These are the paths that are the network paths for access and for movement of data. So we want to control all the 3 paths. So when we talk about segmentation of policies, or segmentation of these resources, it means having controls along those 3 paths, right? And this is something we at Google have spent a lot of time and energy thinking about, like, what are the risks presented by these paths? And one of our conclusion has been, after talking to a number of customers and looking at the overall industry landscape, is there is actually a limited understanding of risks associated with these kind of services, mostly because a lot of us tend to ignore the service-to-service paths, which are actually the most high performance and high bandwidth ways of moving data out of your control, right? So most of us tend to think in classic L3 terms, right? What can I access from my network, right? And can I just restrict the access from a resource to my network? So these are both kind of either you're thinking only ingress control, which is like, what can I only restrain access to a network or to an IP range? Or you're thinking of egress in a limited sense, which is what can I access from my network, right? You're not thinking about egress more comprehensively, which is along all the 3 network paths. So here we, as Google, are thinking about all these paths and making it simple so that you can just set up a policy, and we take care of mitigating the risks across all the 3 paths once you set up the policy. Right. So we'll talk about how we do this next. So what the policy does is the object that you land up creating with this policy is what we call as a service perimeter, right? Think of the service perimeter similar to having your VPC firewalls and putting VMs inside, right? Instead of VMs, here you're adding resources of these multi-tenant services into the perimeter, right? You also land up adding your network, the VPC network into the perimeter, right? By doing so, there is a fairly simple semantic that is used to provide fairly comprehensive security for these services. The first of the semantic is that all access between 2 entities inside the perimeter is allowed, right? And access between entities that cross the perimeter boundary is prohibited, right? With that, we land up, and this applies to all the 3 network paths that I enumerated earlier, right? So as you can see here, but when you set up this perimeter by default, access to these resources from the internet are denied. So they effectively become private to your virtual network, right? Your VPC network. Second, from the virtual network itself, you cannot access things that are considered to be public or outside your VPC, including other resources of the multi-tenant services, right? Like a bucket that is outside the perimeter is an example that we show here. And we can also reason about which private network you want to grant access to. It's not just that we are blocking access from the internet, right? But which private network do you have access to? So another, for example, another compute instance on a different private network would not have access to the resources inside the perimeter. And lastly, you cannot use the service-to-service path. So there are egress controls to prevent you from, or any unauthorized user, any authorized user for that matter, from, but with malicious intent or code with malicious intent, from copying the data to unauthorized resource that is outside the perimeter, right? And we are able to reason about this not just on a single service basis, right? So it's not like the policy says, oh, prevent copying between 2 GCS buckets, right, that are within and outside. We're able to reason about this across service types. So what we mean by that is you can have a flow, a data processing flow that goes, I'm going to read this data using Dataflow or Dataproc, write it to BigQuery, right? Or write it to another bucket. And when I write it to the second bucket, I want to raise a notification that is a PubSub event, which I then would subscribe to, and then write it into a third GCS bucket. And we are able to take this entire complex flow and ensure that it is running inside a single perimeter. This makes it a very powerful and more comprehensive capability than anything that we have built before. And we believe that this is the right way to think about how you protect data with multi-tenant services. One of the key elements of how you gain access from a VM is we have a feature called private Google Access. What that means is, using that feature, you can now connect to your GCP services without necessarily egressing to the internet from your network, right? By configuring private Google Access, you can access it along a private path, and your clients don't need public IPs, and they don't egress through your gateway, right? So effectively, again, this is how you implement the private cloud posture when talking to these services. And we have now extended this to make that posture be available from your on-premises. So your on-premise clients itself, by using either a VPN or interconnect, can privately access these services. And you can make sure that for clients that are accessing highly sensitive data, that those network segments do not also simultaneously have internet-based access to the rest of Google APIs, right? So in that way, you can create a posture that you typically had in your production network, which is very guarded internet access. One more feature, like there are cases where you do want to grant access from the internet. I want to use the BigQuery console. I really like it. I want to use Data Studio to access my BigQuery data. We just did a demo of Data Studio, and it's a powerful BI tool, right? How do you then gain access? Because these UIs that are managed are actually on the internet. They're not accessible through your private path. So therefore, if you want to grant access from the internet, we allow access based upon, as I mentioned, upon both layer 3 entities, right? Like, for example, IP addresses, right? But also with an understanding of identity. So you can say this particular service account or robot account is allowed to access, or this user is allowed to access, right? You can even combine the two. So we have some customers of this who say, OK, my data scientists and data engineers have to go through the private path, right? They won't grant access. But I, as a security admin, want to be able to configure this from wherever. It's a more trusted and a smaller set of people. So you can say these 3 users can access it from this IP range, which might be the NAT address range, the IP range of your NAT gateway, for example, right? So this is the way you can combine both layer 7 as well as sort of layer 3 sort of attributes in order to grant access from outside the perimeter. One of the more advanced features, but we see a lot of our customers using it, is the concept of a perimeter bridge. There are many cases while you have implemented full segmentation. We all know that data is something that you want to effectively share, but in a restricted and constrained manner. So we implemented this notion of a perimeter bridge that allows you to share data while keeping certain data sets private, right, between 2 segments. So it allows you to, so in this particular example, let's say there is one of our customers actually has a constant feed coming in from the internet, which they collect on a pub/sub topic, which gets delivered on a pub/sub topic. They subscribe to the topic, and they write the data into a bucket. Then they take the data, export it to BigQuery, right? Mix it with other private data within BigQuery, and then run analytics on it. And their security posture demanded that the private data remain private, that they never get directly exposed to the internet, right? So if you created a perimeter and put a access level, like I described in my previous slide, on a single perimeter, then your BigQuery data is also accessible from that access level. So here's a way in which case you can significantly mitigate that risk. Only the pub/sub, in this particular case, is accessible from the internet, right? The pub/sub topic, so that you can write data to it, right? And the pub/sub data, if the DMZ perimeter, for whatever reason, there's no compute on it, right? So the chances of it getting compromised and the risks associated with that getting compromised are minimal. But even assuming if that were to somehow get compromised for whatever reason, it only has access to the GCS bucket on the private perimeter, right? It does not have access to the BigQuery dataset, right? And your BigQuery dataset can only be accessed by the compute running inside your private perimeter, but not by anything that's running in your DMZ perimeter. So this allows you to, as you can see, you can create pretty powerful patterns using this set of policy tools that we have enabled for you. The last thing to note is that VPC service controls is a centrally managed policy framework, right? Policy construct. As in, you will have organization level users, right, who configure these. This allows you to set up a mandatory, get your mandatory controls in place such that even as you delegate your IAM administration to the project owners or to the resource owners, right, you can ensure that things that you intended never to be exposed to the internet will never be exposed to the internet, even if it is completely opened up from an IAM perspective, right? So with that, so VPC service control, it's important to remember, is part of a broader network and perimeter security posture that you would like to implement as part of your deployment on GCP, right? So when accessing from the internet, you would typically have some kind of ingress control, and you'd protect the edge as part of your perimeter, right, when granting access into any of your VMs or containers, right? And two powerful capabilities that we do provide on our cloud. One is Cloud Armor, which is like a WAF and has DDoS protections baked into it, right? And the other is Identity-Aware Proxy. So some of the access level that I just talked about before, you can also reuse those access levels, including also adding things like device-based trust. And then those policies can be implemented using Identity-Aware Proxy to grant access to your compute instances, right? And then you can use your VPC firewalls and VPC service controls to establish and secure your perimeter. With that, I'd like to do a very short demonstration of the feature and how you configure it. And then we can talk a little bit about additional policies that we have in place. Can we shift? OK, great. Awesome. So the VPC service controls is available as part of the security section of the console. And you can see there are two relevant pieces here, VPC service control and access context manager. So the VPC service controls area allows you to configure these perimeters and perimeter bridges that we talked about. And access context manager is how you create this reusable sort of access levels, which describe the risk associated with the client when they're trying to access data. And you can then take these access levels and associate them with a service perimeter or with Identity-Aware Proxy as an example. So let's look at VPC service controls and what it looks like. So first, it's an organization level construct. So as you can see, I don't have access to it within a project context. I need to get to the organization level in order to gain access to it. And I hope my internet is still working. Sorry. OK. Sorry, demo gods have not been kind here. I'll try and do this one more time. And let's see if that does anything better. And it was working just before the presentation. Sorry, I'm going to re-get on the Wi-Fi and try it again. Looks better. And there you go. Sorry about that. So I'm going to create so the way to create VPC service control is you start by defining your perimeter object. So you create a new perimeter. And when you create a new perimeter, you can give it a name. So for example, prod perimeter, right? In this case, we're creating a regular perimeter, which is used to add. And the way you add resources is you simply add projects containing those resources, as well as projects that have the networks, right? So I'm just filtering it by some projects that I've created for the purposes of this demo, right? So I have got, for example, a BigQuery dataset, storage bucket in my storage. The compute is the one that has my network on it, right? So I take these three projects, and I said I want to add these three projects. So all resources now, all BigQuery and GCS resources now are, which were in these projects, are now subject to be to be controlled by this perimeter. But at this point, they're still not being controlled by the perimeter, right? You want to explicitly enumerate which services you want the perimeter to control. And the reason for that is sometimes there is some risk that you might want to take and it might be needed in your business application to be able to cross the perimeter boundary using certain services like PubSub, for example, and you may not want to constrain PubSub. In other cases, you just might want to apply to everything that you have, right? So for the purposes of this demo, let's just select everything, right? Over here, the first 10 services. There are 2 additional services here, which is like the Kubernetes Engine API and Stackdriver logging API. Let's first do this, select this. We can add the 10 services. We can go back. We can also then go back and add the logging API, right? Because we might want to care about it. One of the things I want to point out is the way we are thinking about this from a posture perspective is that we're not just saying, hey, mitigate the risk from your GCS bucket in this particular case, right? And we are saying that if you are using Kubernetes Engine in order to access those buckets, you will necessarily also have access to the container registry, right? And it's not very useful to protect the GCS bucket, but not the registry. Because the same risk model that is used to sort of copy the data to another public bucket can be used to just write the data into a container and write it to a public registry. It's no different. So we have to think of this as a systemic problem than a service-specific problem. And that's what we're doing here, right? We're going to create this perimeter. So before I jump into and apply the perimeter, let's quickly look at, and since I had to reconnect, I'm sorry, I have to go back and reconnect here on the Wi-Fi. So let's look at what we can do from on-prem. So one of the things is this is my, the white desktop here is on my laptop, and it represents a client that's on the internet. So I'm running gsutil copy command, ls command, just to see if I can see the data in there. The internet is a little slow, so I'm sorry about that. But as you can see, I can not just read it, I can actually cat it in some cases, and I'm able to see the contents of it as well, right? So I can easily download it at this point because I can access it. And if I can download it onto my internet-based device, I can then write it pretty much anywhere, including Box, etc. Right? Good. We have now managed to log into this one. So the other thing that I can do, which is one of the things that is the most hardest things to sometimes control for, is something like this. I can copy it from a secure bucket to an attacker bucket, right? And I can do this with a single RPC command, right? And when I do this, that's it. And I've moved, in this particular case, a small amount of data, but you could easily imagine that this is a very high-performance way of moving large amounts of data out of your control, right? And it's this command, and since that other bucket is out of your control, there's no way for you to know where the data finally landed up after this call has been made, right? And that's a pretty significant risk, and it's not just because you can move large amounts of data, but because it's so trivial to do this. So now let's set up the perimeter, right? And so I save this, and we now have a perimeter in place that, let's go back and look at it. It now says these projects are inside the perimeter, right? So the compute instance will still have access to buckets inside the perimeter, but should not have access to buckets outside the perimeter and should not be able to copy the data outside the perimeter as well. So let's go back to the compute instance that's inside my perimeter, right? This is the compute instance that's inside my perimeter. So we did the copy, but instead of doing a copy, let's just check, do we have access to the data inside the perimeter, which we should, all right? And we do, right? Let's see if we have access to the data that's outside the bucket that's outside the perimeter. Can I, for example, just download the data into a JSON file on my desktop or server here and then write it out? And I don't have access to the external bucket anymore. So as you can see, we have controlled the path from your network to resources that are actually not inside the perimeter. And of course, there's the backend path. Like, hey, I can't access it directly, but can I go indirectly and then copy the data? And even that is now being denied, right? So you can no longer do this even across the perimeter boundary. And this is a very powerful egress control that controls for all your network paths. you can similarly achieve the same thing even on the ingress side from a service-to-service perspective. I'm not demoing it here, but an example is a BigQuery data set that is outside your perimeter can no longer access the bucket that's inside your perimeter, right? So you cannot export the data, pull it out, create a materialized view there, and it's able to reason about this across two completely different service types, right? GCS and BigQuery, or PubSub for that matter. You cannot raise an event, for example, using PubSub from a GCS bucket that contains, as part of the event, your sensitive data, and then subscribe to it from outside the perimeter, right? So we are looking at this from a systemic and platform-wide perspective. With that, that's the demo. Can we go back to the slides, please? That's mine. Thank you. So that's what VPC Service Controls provides for you. I wanted to touch upon a more sort of comprehensive set of controls that we have on Cloud Platform in addition to VPC Service Control that helps you mitigate the risk. There are some cases where you may not be able to enforce a full perimeter security, right? And the only option you have is not a preventative approach, but a more of a monitoring detection approach, right? And for that, we have threat detection and behavioral analysis of your sort of clients, for example, and code running on your clients. And you can understand your data exfiltration risk because of how your activity has changed, right? And that is shown up in a product that we have called Cloud Security Command Center, which we also launched recently, right? And so that gives you monitoring capabilities, right? So in certain cases where, let's say, a service is not supported or a particular client type is not supported with VPC Service Controls and you must use it, this gives you some mitigation as to whether there's unusual activity happening under those circumstances. There are additional controls on GCP, and of course, you have the VPC firewalls, right? Your layer 3 controls. We have another very interesting control that we have, which can be used for mitigating data exfiltration risks, but only for GKE deployments today, because it is based upon the concept that what you deploy is you authorize appropriately and you know the provenance of it so that you can trust the code that is being deployed and you ensure that it never changes post-deployment, right? That's very hard to implement in a VM-based deployments typically, but you can make that, that statement can be true for containerized deployments. So binary authorization is a deployment time control, right? And particularly if you're using our build systems and source control systems, or even just the build systems, we are able to give you even more integrations, better integrations between them. Even if you didn't, and you just use binary authorization, you can at least guarantee that their signature verification occurs before code is deployed, right? So that helps mitigate risk. It's not a comprehensive mitigation because in many cases you need to access data as part of interactive analysis, in which case the very nature of that interaction is to have arbitrary kind of client logic being applied all the time, right? And you cannot really use binary authorization or a heavyweight approval and signing process in order for you to do that, right? But it's a good control if you have got an ongoing access using a very fixed pattern using clients, right? Then it's something that you can use. The other things that are typically used with VPC service controls all the time are organization policies for configuration control on the clients, right? As well as on the back end. So the first is compute engine. You want to ensure that no compute engine can come up with a public IP, right? In the space and those, in the case where they are trying to access data, sensitive data. So there is a org policy that prevents that from happening, right? So you would want to set that, right? So that now you can guarantee that all your egress is happening via your internet gateway, for example, right? And so that you can control for it. The next is on IAM, right? A very classic threat vector is that overgranting of privileges to everyone, to people outside the organization, and you're not aware of it. And you can prevent that from happening by, again, setting a configuration control using organization policies called domain restricted sharing that ensures that only identities from your org can be allowed or be part of the policies, of the IAM policies for a particular resource. So in addition to VPC service controls, these are other sort of things that you can do to mitigate risk. And as I said at the start, right, like you really need to think of this as a defense in depth and a risk mitigation approach, right? And setting up a secure and well-managed perimeter is a fundamental part of that equation, right? Thinking about it is in terms of layer 7 ingress policies, like what we call Beyond Corp within Google, right? And versus just allowing arbitrary clients who are inside your RFC 1918 address to have access is another very significant part of this equation, right? So you configure the perimeter, you make sure that your perimeter is not weak because you are allowing portable devices that just join over your perimeter to have equivalent privileges to well-managed clients that are also inside your perimeter, right? The two are not the same, right? So you are able to distinguish between them as you gain access, as you grant access, and in particularly as you grant access from outside, from the internet. Then you do want to have appropriate configuration controls, right, to ensure that you can reduce the risk of misconfigured policies across all of these, across your resources. And VPC service control from an ingress perspective acts as a defense in depth, right? As in the VPC service control checks are checked first before IAM is checked. Therefore, if you have disallowed access from a particular identity from the internet using VPC service control or from a particular network location, right? Then even if IAM grants such permissions, it will be disallowed by VPC service controls, right? So from an ingress perspective, it gives you defense in depth. It also provides egress controls, something that was missing, and it provides it along 2 dimensions, network to services and service to service access. And lastly, we continue to evolve this space, right? Providing more comprehensive access controls in terms of who can access and under what conditions, right? So we certainly encourage that you also have, you look at your audit logs and are able to reason about like any anomalous behavior in your audit logs and your access, both on the server side, right, as well as on the client. And you can leverage the Cloud Security Command Center for getting signals from various scanners that we have that detect these kind of behaviors, right? The last tool, which I have not mentioned here, is an open source tool called Forseti. So Forseti is something that scans the policies, right, across your organization, and you can build rules into it in order to understand what your policy posture looks like and whether they're compliant with how you would like it to be, right? So you can also use Forseti in addition to
Great presentation.
Thank you.
You executed your commands and demonstrated access and then denied access outside the VPC service control from an SSH terminal. If you were executing that from Cloud Shell, when you put the VPC service control in place,
yes,
would you no longer be able to access those resources from Cloud Shell?
That is correct. Cloud Shell has unmitigated access to the internet, right? We want to, over time, work towards a version of Cloud Shell that can be part of your VPC, but we deny access. So there are other things for which we currently don't allow access or don't even allow execution in the project. These includes things like Google App Engine or Cloud Functions, because, again, just like Cloud Shell, there is no egress firewall that is available for them. So they have unmitigated access to the internet. Effectively, allowing them inside the perimeter violates the perimeter policy. So we are working, though, with these teams actively to ensure that all of these work together. And through this year, you'll see more and more of services being added, and more and more of these other kinds of compute types like serverless and other compute types be supported. But the first baseline property that we would like to implement there is that egress to the internet and ingress from the internet are effectively either blocked or controlled in order for them to be inside the perimeter.
Thank you.
Hey, thanks again for the presentation. So I have a question around the resources that belong to the projects that you draw the perimeter around, but are not on the list of supported services. What's going to happen to them?
Very good question. That's an excellent question. One of the things we do recommend over here is to make sure that you have reasonable confidence in the project admin kind of role, right? So those who can create new resource types, right? So if you can create arbitrary resource types on the project, you do land up having a risk that those resource types have been created, you have not been able to restrict them, and those are used for exfiltration, right? So number one is to control who can create new resource types within a project. So you want to control for that. There's also activation policies. I wouldn't call it a very hard security control, but it's a soft security control where you don't activate certain APIs on your project, which you can use to mitigate the risks. We are looking at that risk very carefully and are working to mitigate that with some additions to our policy model. I'm happy to talk about it sort of offline, so that you are not exposed to these risks of either unsupported services or new services that get added but are supported but are not restricted by you, for example.
Hi, great talk. So could you please give us the relationship in terms of overriding which policy supersedes the which one, right? You talked about the IAM being overridden by the VPC service controls. How about the VPC firewall policies? I mean, who has the upper hand?
Yeah, that's a great question again. So I wouldn't term it as overriding. We don't override IAM. Think of it like in your traditional network on-prem sort of data center, you had your firewall, and behind that there was some database which has its RBAC policy. Your firewall doesn't override your RBAC policy. It just happens to be executed first before your firewall policy, before it hits the database endpoint, and your RBAC can be executed on the back end. It's the same relationship between VPC service control and IAM. So IAM, think of it as the RBAC that runs, that gives you fine-grained access control to the data. And VPC service control is a more coarse-grained sort of firewall-like policy that you put in front, right, from an ingress perspective. Does that help answer your question? The other question you asked was about VPC firewall and VPC service control policies. The VPC firewall, so VPC service controls only, and I'll go back to a slide which actually explains this a little better visually. This one. So VPC service control, as you can see, only controls for these paths, which are all paths to and between the services themselves, the GCP services. It does not control access and the paths in and out of the VMs themselves. So for example, you can create a service perimeter, add a web server into the service perimeter, make sure that these GCS buckets are never public, right? There is no internet access. But the web server itself is controlled by a firewall policy, which is then exposed to a load balancer and then can be accessed from the internet using the load balancer, right? Subject to, say, for example, Cloud Armor or IAP policies, right? So, but all of that belongs to a single perimeter, right? So the posture you now have is that your coarse-grained access to data or broad access to data happens only inside your perimeter. So only your web server or your middle tier is able to access the bucket, right? That data, the backend, is not accessible from the internet. Now that you have narrowed the data access using application logic, that narrow access, let's say you want to get your compensation information, and maybe that's accessible subject to IAP policies, right? That checks who you are you coming from an authorized device, and grants you access to your compensation. But if you wanted to get at the whole corpus of your compensation database, which is in the backend, then that is no longer accessible from the internet, right? And you need to be in a more privileged network space to get to that.
Very good talk, very comprehensive.
Thank you.
I was thinking, as you were describing these VPC level controls, that with the introduction of Anthos, there's going to be a lot more on-premise deployments that mirror some of these Google deployments. To what extent can we consider some of these as some of the features that you're showing as potentially transparent into the on-premise? Like, how much to what extent do you think you'll be able to treat an Anthos hybrid as a VPC?
We can totally support that. So there are a couple of things. One is VPC service control protects the Anthos control plane itself, right? So there's a piece that we call the connection. Sort of you can think of it as the connection from your database to the cloud, right? Which allows you to push configuration back and forth. That pipe itself, in some sense, that logical pipe, is protected by VPC service controls, right? So you cannot create an Anthos agent that is outside of your network and connect to the API, backend API, and register it to be part of the same domain, so to say, right? You can only do that from authorized network. So it protects the control plane itself. Second, as far as data access is concerned, right? Your on-prem networks, if you're connected over a VPN or interconnect, right, it effectively terminates in a VPC network on cloud, right? And the properties that we just talked about from a GCE VM, for example, are exactly the same properties that apply to all clients inside your on-prem network, including Anthos. And we have 13 seconds, so I take one last question.
Yes, thank you for your presentation. Let's say I have a service control on BigQuery to protect the data.
Yes.
And I would like to be able to make this data available on another project which is not under the VPC control. Is that possible?
Yes, you can.
Using views, for example.
Yes, you can. One is the way you make the data available has to be a service that is supported by VPC service control, right? So there are two ways. One is using a service that is supported by VPC service controls, and you can use this perimeter bridge to create another project that's outside the perimeter and then move the data over the perimeter bridge. So you can do that today, right? The other option that you have is, which is a slightly more perhaps expensive way from a data path perspective, is you can use a client and use your standard L3 firewalls to then tunnel it to another project, to another VM. So VM to VM, and then back to a source, right? So you read the data, and then you write it back out, right? But if you're just trying to create a view of the data, so for example, a classic example of the view, it's not a project, it's like is Data Studio that gives you an aggregated view, and that's allowed based upon the actual IP range that you specify. So you can say my Data Studio, the data that when you're trying to create a report, right, where you're gaining access to raw data, that action can only occur from authorized public IPs, right? And we are able to enforce that because Data Studio propagates those IPs to the BigQuery backend, and we're able to enforce those policies, right? Once you've created the report obviously is outside the VPC service control bound.
sun comes out and it's a new day. I'm gonna make it on my own. The sun comes out.
Hi, I'm Roy Bryant from Scotiabank. I'm going to talk about our approach for PII for analytics. And so we've been doing cloud for about 4 years. About 2 years ago, created the platform organization to build the next generation platform for Scotiabank for all application development. And that covers cloud and data, APIs, DevOps, all that stuff. So I'm with platform organization, shortened to Plato. And I'm VP for the design and architecture, so I'm the chief engineer for that platform. So I'm going to talk about Scotiabank, how we think about the bar for PII in cloud and how that relates to on-prem. I'll talk about just some basic protections that everyone does for applications in cloud and our principles for PII, because our position is that you do the things to lock down your app we're doing. So Scotiabank's been around for almost 200 years. And so we have about 100,000 employees, about 10,000 in IT. And we're the third biggest bank in Canada, and it's Canada's most international bank. So we're in the top 3 in a bunch of Latin American countries and the Caribbean. So we have a pretty heterogeneous environment. We had at one point 69 data centers because we'd acquired 30 banks, each with 2, and sort of going through consolidating that, and we're moving a lot of stuff to cloud. So the latest initiative has been to move the data to GCP, and we're in the middle of that, that journey. So our assertion that it needs to be safer for a bunch of different reasons. So on-prem, if you went to get data, I think this applies to many enterprises, and you want to get data out of existing legacy systems, it's hard to find because there's no good way to locate the data. And then it's going to be spread across a whole huge number of different systems in different places, in different formats, and you've got inconsistent performance and all that. Whereas in cloud, when we ingest it into cloud, we're transforming it into a standard schema, and we have a canonical representation of what a customer is, and we have data discovery tools, and it's all high-performance storage on high-performance network, all in one place, all wrapped up with a bow on it for you. So if you do find a hole, it's going to the big blast radius, and that's going to happen fast. So for that reason, you can't just do what you do on-prem. You need to proportionally improve the security posture. And we're using, we think that the move to cloud is also a forcing function, because what happens is if you try and transform the bank and you just start going around to teams and say, okay, you need to think about it differently, and now let's refactor all the databases and try and refactor 1,000 production databases in place, you'll never get anywhere. But it's an opportunity just to rethink what we're doing for the security posture, and then say, these are the rules in the new world. So if you want to bring in data, then it needs to be in the canonical format, in the standard schema, and we track lineage, so you know exactly how the provenance of each data item and all that, and that's the rules of the new world. So we're using it to just up the game across the organization. So I'm going to talk for a minute about just kind of the basics about what everybody does to lock down an application. So first of all, you want to do the authentication, and that's about who it is that's connecting. So for that, that's our customers, that's tellers in the branch or other people working for the bank, or for fintechs and open banking and trusted partners, that kind of thing. So there can be different types of users. And we want to, and then we have a system where we authenticate more strongly dependent on the risk. So a customer's coming in, yes, you need to tell this is really a customer, and if they're checking the balance, you can make that fairly lightweight, so it's not as intrusive, but if they're going to take a lot of money, transfer a lot of money out of their account, you need to make sure it ups the game. You really have to make sure it's actually them. So, sort of tied to the risk, we would use multi-factor authentication and step that up. So of course you want to figure out if people are really who they think they are, who they claim to be. And then you want to authorize it. So the authorization is just about what those users are allowed to do. So the users would connect at the edge of cloud, so that they would be coming in and they would hit an application in cloud, and that's where we would authenticate them. We would know what they're allowed to do. Within cloud, the different cloud services would connect with a service account. So we pass the identity around for entitlements to data and so forth within that, but the actual services bind with the service accounts. And then you want to manage the accounts carefully. So if you've got the access control list, you need to audit those and make sure people are really still in that role and they have a legitimate need to see that, to see the data, and also just manage carefully the privileged accounts, all that kind of stuff. For networking, we're assuming that yes, even though you're not authorized, if you're not authorized to hit a system, then you shouldn't be able to reach it either, just as typical defense in depth stuff. Encrypting at rest and in flight, sure, yes, everyone should do that, and it's good that cloud does it. I don't think the attack vector is actually somebody breaks into a data center and runs off with a drive, and then, so it's more, and I don't think it's sufficient to just have transparent encryption that you're able to just easily decrypt. So I'll talk more about encryption. And then just a bunch of hygiene stuff about, keep your patching up to date and harden images, all that kind of stuff. So that's just all the basics about how you lock down an application, which is I'm sure, all the basic stuff that everybody knows. Then there's the next layer would be infrastructure as code, and disallowing interactive edits to it, and have approvals for pull requests and more scrutiny for sensitive ones. If it's got changing a firewall rule, you'd want to get approvals from security as well as other people, all that kind of stuff. And then that to just reduce the risk of either accidental changes or malicious insider changes. And then I think the bank's done a good job of articulating the security control objectives. There's a good list of hundreds of controls that need to be enforced. And then, when we build infrastructure pieces, we run the tests for, is it compliant with all those controls? So, and then the first bar that we implemented was just that applications can be made safe. So we just make sure the platform, if you use the platform properly, then you can make the application safe, and then you can demonstrate it is safe with a bunch of tests, and that was the bar. The next bar that we're enforcing now is that using the platform, anything you're building on Plato, you can't do anything unsafe. And then that lowers the bar for what you need to do as far as scrutiny and getting approvals for launch and all that kind of stuff. So is the bar we're enforcing. So that gives you pretty safe applications, I think. And I think that the change control should probably keep them safe. But that's about locking down the application and not really about so much the data at scale. And I think that it's insufficient for PII, for analytics. So we've established some principles that we apply to PII. So the first thing is that we tokenize when it comes in. So by tokenizing, I just mean that we encrypt each item of data as it comes in. So instead of just encrypting the data set and then transparently decrypting it when you see it, as it comes in, each individual item you would tokenize. Looking at it, it is a token and what key to use to decrypt it and all that. So it's an object that you can manipulate. So we tokenize on the way in. Another thing is that we want to make re-identification rare, because actually you can do a lot of common operations you can actually just do on the tokens. So if you're you're doing machine learning and you're training a model to look for credit card fraud, you would look at what the size of the transactions and the pattern, the timing, the geographical location, all that kind of stuff. All those are good signals for training the model. You're never training it on, it starts with the credit card number starts with the digit 4 or something. That's not a useful signal. So you can do it just on the tokens. I'll talk more about the re-identification. And then for this approach of governing the intention instead of managing the artifacts, I'll talk more about what I mean for that. So the tokenization, as I said, we're encrypting each piece of data as it comes in. So the credit card number comes in, it's 123, it turns into a token ABC, which is actually a big long opaque string that's meaningless. But it's globally consistent and unchanging, so you've got referential integrity. So you replace the credit card number with a token that will always be the same, and if you're bringing it in from 10 different back-end systems and you bring it in today and in a year, and if you notice a credit card number in some unstructured text, it'll all be replaced by the same token. So you have joinability in the data sets, you just can't see what the content of the original PII was. So we tokenize it during the ingestion. We do the transformation to standardize it into the canonical format and so forth, the standard schema when it comes in. And we do that, we're using Cloud PubSub and Dataflow and DLP to do the encryption. And we're pretty happy. I think it's pretty moderate cost. It's less than about 5 milliseconds to do the encrypt or decrypt. And for 100 byte strings, it's about 3 cents per million records. So not too bad cost-wise, cost in performance or money. And so now you have the opaque tokens, and so and then they can flow freely around the system. So you've got the tokens, applications can just read them and manipulate, pass them around, copy them, all that is all pretty low risk. And we do in fact enforce RBAC rules for what data you're allowed to reach, but it's just less sensitive just because it's not valuable information. And as I said, yeah, so that we can do a lot of the training against it on the tokens. So that goes back to this being a rare operation to re-identify. So this idea about governing the intent instead of the artifacts. So in the example, let's look at for zero trust networking. The reason that zero trust networking is nice, you just make the direct connection between the two ends and you just don't trust anything in between, so you just use mutual TLS. So in that, you just go, okay, this service A can talk to service B, you need to lock that down, and then, which is nice and straightforward, so, you can then remove that. Whereas if you look at the artifacts instead, that the artifacts that you create. So if you do it with, these two services need to talk to each other, and to implement that, you open up ports in firewall rules across 10 different firewalls, and then you make that work, and then you do that for 10,000 systems, and then now you have a bunch of rules, and then you say, okay, these two don't need to talk to each other again. You'll never actually fix the rules because nobody knows how to remove the rule without breaking everything. So it just sort of is, it's just hard. When you know the intent was these two should talk to each other, that's easier to manage. But if you're trying to manage the artifacts, there's just so much noise, it's a lot more complex, the signal gets weakened and it's harder to deal with. So that idea from zero trust networking, which we're applying to zero trust PII re-identification. So we're managing the intent we're managing it in the same way for zero trust PII, the same way as we would in zero trust networking. So I'll just walk through a little use case to illustrate what I'm talking about. So you have an application ABC that you want to, so it's say a teller application in the branch. The teller's using it, and then okay, they need to look up a customer record, the customer's standing in front of them. So you want to get 20 items of PII. So then now you want to do that in this zero trust environment to be able to achieve that. So I'll walk through, kind of what the pattern is. So what you would do is, and this would all be hidden in libraries. It should be transparent to the application development. So you would ask a PII manager, which is part of Plato. So in this, everything, the first application ABC is a cloud application, but outside Plato, built on Plato, but not part of Plato. Everything below is Plato. So you would ask the PII manager, and that's a legit use case. This application is allowed to see Canadian data, and it's allowed to see up to 1,000 items at a time, so this is within that. So then it would grant a certificate to, that the application can then use to delegate its authority to re-identify. So now when it makes the call, it makes the call to the API saying, okay, I'm making this call, and if anybody needs it, here's it'll hit Spanner, and it'll be all tokenized data. So it could either be, you're looking for what are all the transactions associated with this customer, or if you're doing a query against tokens, then you would say, I want to look for all the transactions for credit card 123. It would look up the token for that and it'll go ABC, so it does a query for what are all the transactions for token ABC. So you get the set back. And then, so you would get a bunch of, so now that query returns, so now XYZ has a bunch of tokens in hand that it wants to re-identify. So as this certificate passing it into the system now, XYZ sees it and goes, okay, I've seen this certificate pass by, and I sign. I've now seen it. It looks good to me. It can constrain the permissions if it would like, or just pass them on and sign it. So the application passes in the certificate and its public key for encrypting the data back. So now you want to re-identify. So now it calls the re-identification service with the signed certificate that it's signed saying, okay, it came from ABC, it's now passed through XYZ, and here's ABC's key, and it calls the re-identification service. So now the re-identification service calls the PII manager and says, okay, is this certificate legit? Is this really, did you issue it? Was it really on the whitelist? Yes, it looks good. That's the right key, all that. And then it just, it keeps a tally of how many pieces of PII were re-identified in that certificate. A bunch of this can be kind of parallelized and so forth. It's not really a performance problem. And then it goes, okay, that looks legit. So it calls DLP and gives it the token, reverses that back, and gets the PII. So now the re-identification service has the PII in hand. So what it does now is it takes that clear PII and it encrypts it with ABC's key. So briefly in memory, there was the token, it passed the token down to DLP. It comes back with clear text in TLS, but clear text, and then that'll encrypt that so it's now ciphertext. And now the ciphertext gets returned to XYZ. So XYZ returns it back to the application. The application uses its key to decrypt it, so it gets the payload, it gets the piece of PII. So there's a couple of nice properties of the system. So one is that we assume that the security will be defeated, and somebody's going to, because if somebody gets in, the attack is going to be, they're going to get in and somebody's going to run arbitrary code somewhere in the system. So here, if you do hack in, all you see anywhere in it, if you're just passively sitting in XYZ, then all you'll see is some tokens will pass by, and then you'll see some ciphertext pass by, but you don't actually see any PII. And because it's encrypted, it's either tokens or ciphertext, so it's encrypted at rest, it's encrypted in flight, it's also encrypted in memory, so you never actually see the PII in the clear. So if you hack in and you get into XYZ, it does you no good, you don't see any PII. And then, and if you're actively trying to attack something, you can hit the storage and you can read some tokens, but you can't re-identify. You can call the re-identification service, and it won't do it for you because you don't have this signed certificate from ABC. And what you actually need is you would need that, and even if you hack so you hack into the re-identification service, so now you have the power to re-identify, but you don't have access to tokens. So you can't, by hacking a single system, get the PII. So it's zero trust. The other nice property is that you get, as the certificate gets passed down the stack, you see that this one came from ABC, then it came through XYZ, and it was signed, then re-identified here. So you actually have the clear intention that, you know, ABC needed to re-identify this much data for this user at this time, and you have the call stack, the trace through the system for all the calls for that PII. So it makes it really easy in a machine learning context to just look at, instead of you've got a billion calls through some API or whatever, and you're trying to parse it out, you just have, you know, this call for re-identifying PII took these 4 hops through the system. And then you see something that comes in from a side channel. You have whitelist for who's allowed to call the re-identification service. So you know it needs to come down through that path. If somebody calls not on that path, you can tell, because, you know, it's obvious that they've defeated something. You can see what all the normal call paths are. So just because it's a lot cleaner signal, it's a lot easier to see anomalous bad behavior. And again, you can't get any PII, and it's zero trust in the same way as zero trust for networking. So we're building this in GCP. We're really happy with the relationship with Google on this. Partly we picked them because the strength of the technology is foundational, you know, performance, security, all that stuff. Partly we've got a good relationship with the engineering teams. They're helping us build stuff, and they're listening when we're putting in feature requests and being pretty responsive there and helping us get that delivered. So we're using DLP data flow on the ingestion. We're using it to, for the structured data, we're encrypting the structured data as it comes in. So we know in this record, this call, you know, this field is a first name, this is a last name, so forth. So if we know that, you know, we know which fields are PII, then we tokenize those. And then we also use it to scan for unstructured data. So if the data's in, but it might contain some PII, then we'll scan it using DLP. And we'll find, and then it uses regular expressions and machine learning and so forth to identify the PII. And in that, you'll get the token. So if it sees a credit card number in there, it'll tokenize it in the log or the unstructured data or whatever, and then the same token would be assigned to that if it came in as structured data. So then you're seeing, okay, in the log, you see you know, you can see in the token, you see it's a tokenized credit card number, and then you can look in there, and then it's and then you can go join it with structured data from everywhere else, and you know, you can still reverse that. And if you need to, you can re-identify if you've got a need to do that. And then we're using Cloud KMS to manage the keys, which we did the crypto team at the bank did a whole assessment, came out happy with the whole way that all works. We're quite happy with that technology. So, so just to summarize that, you know, kind of the way we think about the PII for analytics. So if you're coming in for a use case of just there's some PII that a single application needs to access, then you already have the zero trust. You've got an application and it calls a database. You can just encrypt in that database. It's a simple relationship. And then you can go, okay, so the data in the database is okay. It's only connected by a single application. You can lock down that application and you can understand the access pattern, make sure nobody else can hit the database, so it's a nice understandable pattern, so that's okay. Where we tokenize is where you have data that, like for analytics, where you have the data needs to be hit by many applications. So if you've got 1,000 applications reaching the same data, you can't be satisfied, you know, you're secure as long as you lock down all 1,000 applications properly, which you'll never get right. So, which is why we need to not trust. So we authenticate, and we're really careful about that, but we assume that somebody will defeat it. And then we look at whether you're authorized to be hitting there, and we're really careful about that, but we assume that unauthorized access is going to happen. And that, and then so we constrain the network, so you shouldn't be able to reach, you know, these two systems aren't allowed to talk to each other. You shouldn't even be able to reach it. We assume, okay, they will find a way to reach it. Somebody will break something, an insider will open a hole, whatever. So all those, we just assume that those will be defeated. And then we have this rule that you can't have, that no single hack is going to get data. So If there is a hack, then you just need to detect that quickly. You can see anomalous calling patterns. If it's coming in on an unapproved path, you can notice quickly, because the calls in the logs, the call is not going to be paired up with a legit call. It's going to pretend it was called from there. You can compare the two and flag that quickly. So there's lots of those scenarios you can catch from the logs and alert on that and shut things down. So we assume that hacks would happen, and we want to detect that quickly. And then we want to track the intent for the PII and not trust the rest of the system. So, and the important principle in that is that you track the intention to do the re-identification. So up front, you want to track that there was a legitimate need for this application to see some PII, and so you vet that. You do it against your list of what data is that application allowed to see, who would be allowed to see that, constrain the applications. You have this much data, the application is allowed to see this much, the user is allowed to see this much of that, so you scope that down and enforce that, and then pass that through the systems, which gives you a nice clear signal about what was allowed for what time, track the whole flow through the system for how that goes to see, so you can detect that. And then just because you got a nice clear signal, it's easy to detect anomalous behavior. So you're going to be able to see, I didn't expect a call on this path. For every call, you have the path through the stack tied back to the delegated authority in the certificate. So the result of this is that no single hack of the cloud, the data platform on cloud, results in any data, and it's zero trust. So, and the reason you can't get anything by hacking a single system is everywhere except for, so the application has, anybody that proves they have a legitimate business need to see the PII are granted it. They're given the authority to delegate that through the stack so that the right things can happen. But everywhere else in the system, it's encrypted at rest, it's encrypted in flight, it's encrypted in memory, and malicious actors just never see it in the clear. So if it's never in the clear, there's not very much they can do. So that's the basic use case. I want to sort of run through that use case and leave some time for questions. While I'm here, so we're implementing this. I'm hoping to get some support from Google Cloud to be, it seems like something that could be supported in Anthos. I think that all this passing through the call, because it's the same mechanism basically as you want to be able to trace calls through the system, and you can do that in Istio, and you know the calls, and they do that by putting an identifier in there, and you can put payloads that will get called down into the tree, the call tree. So you should be able to do the same thing with the certificates, sign them. So I think native support could help with this. I'm requesting that this PII manager to create these certificates and then sign them and govern it and put in the building blocks for zero trust PII management. I'm pitching that I would like them to build into Anthos. So having those conversations. And that's what I have to say. Any questions?
Just a quick question from me. Do all service requests start with a certificate? So the consumers, like the client consuming the data, does it need to always have a certificate, or do you use different sort of credential?
It would, if you need to re-identify, you would get a certificate. I mean, you could optimize if that's a problem, but it's already in cloud. It's getting get a certificate from the call to pave the way. So yes, you would typically do that.
Okay, so is that like a dynamic issue, a certificate, or does it sort of stay with the client for some time?
Sorry, say it again?
The certificate that the client furnishes, does that stay with the client for a period of time, or is it sort of dynamic? I'm just trying to understand how quickly they get refreshed.
Right, so when you request it, you would do per call, basically. So it would let you, I mean, I guess you could take it for a couple of calls, but you'll get a request for, over a short time period, some set amount of data, and then you could do that. It would typically be a single call.
Yeah, so like an ephemeral type arrangement. Okay.
Exactly.
Right,
and then they would expire and you stop tracking.
Okay, thank you.
Okay, no problem.
So you guys have global tokens with referential integrity.
Yeah.
How do you handle like key rotation?
So we rotate. So the data encryption keys don't change. So that's not the problem. We do rotate the key encryption keys. So that is what we rotate. And then we're actually we're actually also looking at a second set of, like, have a second set of tokens and then with a hash of it. So there's 2 keys involved, so that you would not need to rotate them and you can track. It's sort of a primary, secondary. You know, when the primary's down, then you would need to, then you're running on the secondary for a while, you want to get back onto the primary, like that kind of running a degraded mode sort of thing. So you would have 2 keys in the encryption. You would have 2 keys to result in the token. So if they would be secured separately, completely independent systems. And then if one got breached, you would need to roll it, but it's not as urgent. So if you actually had to roll it, usually it would be okay to roll the data encryption keys. You can roll and then you get a level of indirection. So you can roll the key encryption keys, you can roll the data encryption keys on reversible tokens. You have non-reversible tokens that you don't need to roll unless one of the keys is breached, so it would be uncommon. Okay. That's the approach.
Thank you.
Okay, no problem.
Hi, you mentioned a whitelist of valid intent paths. Is that a whitelist of this client can access this PII, or this client can access this PII through this particular path, or through a particular API call?
Right, because you can set it up either way. So,
either or both?
Yeah, so you would. So I mean, the basic thing is that this application is allowed to see this class of data. You know, this banking application is allowed to see Canadian data in this volume, all that kind of stuff. So then it would ask. It would be granted that, and then you can further constrain that if you want to. And then it needs to come in through the APIs, which would be normally here are the customer API, you know, the customer-facing APIs, that abstraction. So you would be coming in through there. So if you know where it's coming in, then you can constrain it that way. And then you can enforce that when it came through the system, it followed the right path.
I see, thank you.
No problem. I have one question, which is, so this stronger posture of zero trust on the PII, how do people feel about that? Is it excessive or reasonable or? Sorry, a good, reasonable? How many, if it was part of cloud, how many people would use it? Okay, thank you. Any other questions? One more, okay.
So do you see the scope to consume this type of pattern for on-premise, so like using Google services to apply it to some of the on-premise data assets, so like big data?
Yeah, I mean, I think this mechanism is general. It isn't a PII pattern. It's a zero trust for, yes, it's good for passing information around and make sure it's encrypted. It's also just a way to lock down critical calls. So you want to know, is this call to this API legit, and grant short-lived permission to call, you know, this way through the stack at this time and be able to track that. So I think it's a general mechanism. So in the bank, like, we're building it for PII, but I think it's more broadly applicable on-prem and in cloud and on-prem.
And is there any sort of technical constraints at this stage to do that? You mentioned the use of, I think it's Anthos, was it? Or just trying to understand where you are on that journey.
Yeah, so it depends. So so Anthos and, you know, Istio or whatever. You need to be able to. Ideally, we use that to carry the payloads because it's a nice, convenient way that you can say, you know, I'm making this call, and all the resulting calls tree all gets that certificate. So it just propagates it out. So if you're in an environment that doesn't have that, and you're calling into on-prem and you need to do it, then you would just need to provide a library on each hop. You would sign it or just pass it around as a, you know, you don't have to use a sidecar to do it. It's a nice way to automate it, but you could just pass it around. So the same mechanisms sound. It's just whether you get a little bit of help from the system or not.
Okay, thanks.
quick question.
Sure.
Just one quick question. You spoke about using the Google key management.
Yep.
Have you guys thought about hardware encryption modules and HSM type needs in a cloud world?
Right. So like using our own HSM or
probably dedicated HSM connected into GCP in general.
Yeah, I mean, I think Google does a really good job of managing the keys, and so providing the infrastructure. So we're not supplying keys. We looked at it and actually, passing the keys around and then supplying it without, outside KMS is less secure than having the key encryption keys not leave the platform, and there's no way to extract those. So we do that. So we manage the keys, but we do it in Google infrastructure for the keys used around the tokenization and everything. So we did that, and then, as enhancements come out to the KMS, the key management system stuff, we'll use that. But I think we felt comfortable that where they are now is sound, and I think it's the same infrastructures they use to protect internal Google assets as well. I think it's well run and well thought out.
All right, thank you.
The question I have is, it sounds like that all the API, all the data access has to go through the intent of the access validation with the PII manager. Is there any consideration the PII manager could be a single point of failure?
Sure. And with the encrypt, I mean, you would have to. Yeah. So I guess it could be. I mean, you would have it highly available. You would have it replicated out. You could hit any of the replicas. The same sort of way that if DLP went down, you wouldn't be able to decrypt if you're using DLP or whatever. And I think that's, a robust system.
I guess the question is in your architecture of the design, and when you design the PII manager, and is like the multi-region or kind of the it's highly available type of the design? Or, I mean, I just want to kind of get a little bit more out of it to
right.
be sure
Yes.
that because every single call will go through the PII manager.
So you can you would cache, you would do it once per certificate. Like you would get the certificate, right. So you would when you establish the connection, it would go, yes, the certificate's valid. Like you would call it, you'd get the certificate, it could pass it over at the same time, pass it over so you have it in hand, and then you would cache that. So it says you can do 20 pieces of PII in the next 10 seconds. You wouldn't call it 20 more times, right? You would cache that. So I think that's okay. You would run it. You would run replicas within the region. You would run multi-region. We're going to do it multi-cloud as well. So we're in Azure and Google. So you could then, if you've got data, we would use the same tokens in both clouds and on-prem eventually, and then you could re-identify on-prem or in either cloud, and you could do that locally without having to go back, because that would all be replicated across. So you could go hit a different re-identification service, if you needed that. So I think we can. So I think the availability and the latency and all that, I think, is a solvable problem.
Thank you.
Okay, you're welcome.
Thank you a lot for this sharing. What was the time frame of this project? How long did it take?
So we've been in just trying to get PII into cloud. I've been at the bank for about 18 months. I had been at Google for 6 years before that, and then I've been at the bank for 18 months. So the first step was getting approval to get the tokenized data in, and then we're working our way through the different re-identification patterns and so forth. So we're now ingesting a bunch of data, and we're sort of just working our way through this, and we're building it ourselves as a layer on top, but our preference is for it to be natively supported. So I'm doing a lot of talking to the Anthos people this week to see if we can get it, get some lower level support for this, so we don't have to do all the heavy lifting. Because I think it's a pattern that's more generally useful, and I'm hoping that Google will add it to the platform. zero trust PII.
Thank you.
Yeah, you're welcome. Hi.
Hi, thank you for sharing your architecture. It was very informational. I have two questions. Looks like certificate is being passed around through all the calls throughout the stack. Were there any concerns of the message being passed around being big? Because certificates can get big, first question. And second question, you talked a lot about all these design principles which were considered before coming into the architecture itself. Were the design principles learned from mistakes, or were you proactively looking at points of failure and then addressing them coming to this design? Thank you.
Yeah, so the principles that came in, well, we came in saying, you know, so I think quite a few people sort of trying to tackle PII in cloud will get, you know, for this use case you can do it, or for this application you can sort of bring a little bit of data in. What we want to do is we wanted to get the whole data set in, so to unblock machine learning against it and so forth. So we wanted to do that, and then we started, so we looked at it from the perspective not just of the, you know, for this individual use case, what do we need to do? We looked at what fundamental principles do we need to apply to be able to do it, you know, before we would be, you know, allowed to do such a thing. So that became, you know, it needs to be zero trust, and there needs to be, you know, all the common exploits that, you know, whenever data leaks from cloud, all of those attack vectors would yield no data, and that became the bar. So that kind of drove a lot of the design up front, and then, yeah, sort of iterate from there. Hi.
Hey there. So I just wondered, is this something that you've considered open sourcing? I think that would be a really cool move, that you could kind of engage the open source community around this.
Yeah, yeah. We're looking at that. We have open sourced some of our stuff, and would like to do more. I think we would like to open source it. I'm hoping also that it's in that gets added to the platform, and so, you know, so it'll be supported by them, and then open sourced in the platform would be ideal, I think. Because like from our perspective, like we're super safe, and if we're safer than our competitors, that's not a competitive advantage. If anybody gets hacked, it's horrible for everybody. So anything we can do to get everybody following safe practices is just better for everybody. So yes, I'm in favor of it.
Awesome. Thank you.
Okay. No questions? Going once, twice? Okay, thanks a lot.
Awesome. Good afternoon, everyone. My name is Francisco Uribe, and I'm the product lead for the computer vision and AutoML platforms. In today's talk, I'll be delighted to introduce the computer vision platform, and then I'll turn it over to our friends at UiPath, Infogain, and Automation Anywhere so that they can describe how they're using our technology to make their robotic process automation technologies better. So the mission of the computer vision team is to enable our partners to build the next generation enterprise AI solutions. And this focus on the enterprise has led in the last few years to significant breakthroughs into the application of AI across different verticals. Like for instance, we have industries applying our technology to detect damage in their facilities for predictive maintenance use cases, or media and entertainment companies using our technology to implement intelligent content management systems. And the focus of this talk, companies are using our OCR and natural language understanding technology to derive insights from their data, provide structure, and automate complex business workflows. Now, to recap, the computer vision platform is comprised of two sets of products. The first set of products is our pre-trained products, and the second one is our customizable AutoML products. The Vision API allows you to build models or use models without having to code. It's completely plug and play into your application. AutoML products can be customized with your own data, leverage behind the scenes Google's state-of-the-art neural architecture search, hyperparameter tuning technology so that you can build high-quality models with it. And this is great for more complex, specialized use cases. Now, these two categories of products provide you a fairly comprehensive set of tools to implement computer vision models. But we know that AI tools are only part of the equation in what it takes to build enterprise AI. Enterprises today are still facing significant challenges wrangling their data and seeking buy-in to actually deploy these models at the last mile. So for that reason, in Cloud AI, we determined that it was critical for us to democratize this technology, to partner with key companies so that jointly we can solve the enterprise's deepest challenges. And one key challenge that most enterprises face today is that 90% of their content is completely dark and unstructured and requires significant amount of human effort to be able to understand and integrate into a business workflow. So for that reason, yesterday we introduced Document Understanding AI. Document Understanding AI is our partner-led solution to help you understand structured data, things like invoices, legal documents, tax forms, and then automate business workflows and improve your decision-making. For instance, processing an invoice today is a very, very tough task. Today, when you get a physical invoice, a human needs to type the fields directly into an ERP system. Now imagine having to do that across tens or even hundreds of thousands of invoices. It's a lot of work. And it's very error-prone as well. With our technology, we can turn a scanned invoice into a digital structured JSON with all the fields, so that then together with our partners, we can integrate this data into a downstream business process, like a P2P business process. So this is, we believe, very transformational. Now, at a high level, Document Understanding AI helps you structure from your unstructured documents with the goal of implementing better organization of your data, enable search, and on top of that, you can automate repetitive business workflows and improve decision-making. And now to explain how Director of AI at UiPath, and Ravi, Senior Director of Digital Services at PepsiCo.
Excellent. Thank you. Thank you, Francisco. So I'd like to start off by talking a little bit about who UiPath is, in case you're not familiar with us as an organization. We are today now we are the fastest growing organization in enterprise company software history that's growing at the pace that we are. We have over 2,000 enterprise global customers that are using our platform on a regular basis. And we have over 1,500 UiPath employees that are growing daily inside our organization at a pretty steady clip. We have over 300 partners with whom we work with in a very large, rich partner ecosystem that enables our platform to be as robust as it is. We're invested by multiple investment partners. We currently have $400 million worth of investment, $3 billion valuation, and we are recognized as a category leader for RPA, robotic process automation. From a sponsorship perspective, we have great sponsors, including Excel, Capital G, Kleiner Perkins, and Sequoia as examples of the companies that are backing us in this space. And just real quickly, from an overall perspective, what is robotic process automation and what's UiPath's specific view of this? It's really about enabling the easy deployment of scripts that can take the work that humans do on a daily basis and automate those tasks on a highly repeatable basis. So these tend to be rules-based scripts that we can basically then mirror what the human does on the screen, working with applications and moving data from one application to another. The way that we make it very simple is that we work at that UI layer, hence UiPath. So the integration doesn't require us to work, if we don't want to, necessarily at the API layer, or worry about going down into the services layer or the data layer to be able to perform this type of integration. So if you want, you can integrate UI layer or API layer as well. The other compelling aspect of why our customers are finding so much benefit from the platform is it's a low-code environment. So business users can actually start to work with our platform today to simulate maybe a particular process area that they want to automate, and they discover that they can actually do that process without having any type of programming skills and take that process and advocate it inside the organization, ultimately to be implemented as part of a production effort. So one of the interesting things that's happening in the RPA space is kind of this beautiful marriage between RPA and AI. And so AI is really going to enable a next generation capability of smart robots, so that fundamentally we can shift from robots that are basically performing those rule-based tasks that are highly repetitive in nature, and ultimately transition that to more of the increasingly complex tasks that exist inside an organization that can't necessarily be codified by rules and that require more cognitive type of capabilities. So when we think about AI or machine learning, how can we use those capabilities like forecasting and probabilistic modeling and scoring and deep learning type of capabilities, including computer vision, to enable robots to be able to have these new skills, to be able to do better work, more work inside of the enterprise. So we see this as an inflection point, actually, and it's fundamentally going to transition the industry from this rules-based structure to a very intelligent-based robot that, again, can take on more of the tasking that we do inside of enterprises today. Now, if we take this and we actually apply it to the space of document processing, so every enterprise in the organization deals with large volumes of documents of varying types throughout the organization. And what's important about those documents is that key business data is locked up in those documents. And sometimes those documents are in print format, and we have to digitize them to be able to get that data in some type of electronic format. In other cases, we have a digital document that we can get that data from. But the important thing is, how do we get that data out reliably and quickly so that ultimately we can move from data to insights? Because that's really what's important to businesses. I want to unlock that data from my documents. I want to be able to get insights and do further knowledge mining up against that data. So what we can see here is, as an example, what role does a robot have in that? The robot can help automate the process of collecting documents within the environment. So it can ingest documents from an email box as an email attachment, maybe invoices coming in from an email. If there's a file storage system, it can inspect a file system and fetch documents from there. If there's a blob storage type of environment, it can also pull documents from there. So that's a great skill for a robot to be able to go look for the documents that we need. One of the benefits that we can do is once we have that document, then we can assess the document features and know, for example, a particular document type is an invoice and that we need to process that invoice in a particular way. So we provide a lot of capabilities, working on the capabilities within our platform to be able to look at the pre-processing aspects of that document, extracting the data from the document, and then any type of post-processing activities to be able to get that data fit for downstream into production-based systems like an SAP, for example. So the value there is that when we extract that data, we get that data in a very common data format, in a kind of an intelligent JSON structure, which gives us key value pair information, the extraction of table-level details. In addition to that, we know the confidence level information that comes from the algorithm relative to how well the extraction was performed. And that's really important because we can set a lot of rules up against that type of data to be able to treat high confidence data differently than perhaps low confidence data. Also, when we have this data, there's a lot of things that we can do with respect to leveraging classifiers. So we can have document classifiers that can find a document that's an invoice or a healthcare-based document or a benefits-based document. So it can treat those documents in a different manner. We can also use that data naturally to be able to support additional machine learning models around scoring algorithms or specific custom fit-for-purpose models that are appropriate for a particular business domain or a functional area. And then essentially, once we've got that data, the robot can actually work with the human to be able to accomplish a mission. So this is all about humans and robots and AIs basically working together. The way that they do that is through a human-in-the-loop process. So as we'll demonstrate later today, we can actually extract that data, and if it doesn't meet that minimum threshold level of the confidence details that come in that JSON payload, we can go into a human-in-the-loop process so the human can actually see what was extracted and then correct or validate certain features from that data extraction before it goes to downstream systems. After that process, the robot can pick it up again and populate Google Sheets or go into SAP or go into a variety of different landing sources that would include perhaps some data repositories for the data mining side. So from an AI and RPA case study perspective, where this individual use case is for invoices, but the capability can support documents of many types. Invoices traditionally tend to be manually processed, so there's a lot of effort associated with getting the invoice up and running. And invoices are interesting because they have many different multiple feature sets. So we see machine-generated text, we see handwriting, we have objects on there like signatures and the logos. So it's a consistently hard problem to be able to actually process these documents at scale. And so we're changing the game by working together and bringing our investments in AI and our RPA platform and our partnership with Google through Google's Document Understanding AI capabilities to be able to help reduce the costs and errors associated with that manual heavy lifting of extracting data or swivel chair when I rekey the data into a terminal or into a screen. And then I can, as a result, benefit from increased efficiency and greater speed, and then start to look at things like fraud and fraud detection in some of my invoices that might be in a particular market where we've detected higher fraud. So the approach is to extract content from the forms and tables, and then basically allow that human loop process system to begin. And we'll actually demonstrate that capability later on in a video presentation. But at a high level, essentially what we're looking at is the supplier invoices can come in, the robot can pick it up, it passes it over to the document processor from UiPath, where we then interact with the Google Document Understanding AI to be able to get the extracted value out. If we need to perform that validation step, that begins that human loop process. And then the robot can pick up the document afterwards, after the humans validated or refined the data, to be able to carry it over into the back-end systems. So with that, I'm going to pass it over to Robbie to talk about how we're actually applying it in his environment.
Thank you, Mark. So with co-innovation with Google as well as UiPath, here I'm going to demonstrate a sample representative use case that we have experimented with and have proven the use case. And here we are seeing a sample that is as close as possible to the representation of every feature that we just heard from Mark, like ranging from unstructured data to the computer-generated, machine-generated data is also there. Handwritten signatures are there. Seals, approval seals are there. And within the seal, again, there is unstructured handwritten information is there. So different types of unstructured information is available. So gleaning information, insights from that unstructured data is this use case. Essentially, we have here all of that information, and most importantly, how the bot from the UiPath platform is able to dissect that information, different types of notations, and is able to progress forward. And when it works on that information, it makes an API call to the Google Document Understanding AI feature, and then the response is coming back, as we heard from Mark, in a JSON structure format. And based on that information, to a certain level of confidence factor, we're able to decipher the unstructured content information, whether it is the key value pairs, including invoice number, the date, the supplier details, particularly the most important one, the transportation number, and number of similar key value pairs are extracted. And it is intelligent extraction. And more importantly, it's the line item detail with the table parsing, which is another very important and powerful feature from this Google Document Understanding AI API call. And with that, knowing that extracted information and the quality and its confidence level is extremely important. We could predefine certain thresholds, and then once the threshold is met, the bot can proceed automatically to update the back office systems, whether it is ERP, SAP, or any other back office system accordingly. Like the swivel chair type of information is not required anymore by the humans. The bot is able to do that. You can see the bottom picture, how that is dissected back with the response into opportunity for human in the loop and to override that information. Do a side-by-side comparison like this. You have the original invoice as well as the parsed information side by side. And then the human, the analyst, is able to make an override if needed based on the threshold not being met by the API call returning the JSON structure, which is seen here in the picture. And after the review, the bot can continue once the human in the loop is updating, and then the next step, the bot can proceed and then update the back office systems as required. Here, like I mentioned earlier, parsing the table structure is very important. One powerful feature here worth mentioning is it's not per specific table structure that you have to templatize. No. This one is a powerful computer vision-based intelligent extraction feature in that API call we make. And that's why it's worth mentioning that parsed information is shown in the UiPath Studio on the left side image. On the right-hand side is the actual invoice on which the extraction was done. And the validation station is providing that view, and then if a human in the loop is there, all those fields can be updated and overridden. If it is meeting the threshold, then the system proceeds to the next step automatically. And also additional feature that Mark mentioned is robots can use intelligent classification. There is inbuilt feature for geography-based detection or candidate for audit kind of detection. All these are classifications that are available in the platform with UiPath platform, and then you could dissect that information and classify them into these kind of categories in the picture we are seeing here as the representation of categorization. For example, on the right-hand side, you can see after the threshold, certain amount level, you want to automatically have an audit mentioned. So the bot catches it, and the platform, UiPath platform, automatically mentions that it is candidate for auditing. Those type of features are all built in. This is ML-based, AI, computer vision-based, combinatorial use case between the Google platform and the UiPath platform. And we did the co-innovation with both the partners. And with that, the benefits are of numerous cases, right? I mean, it is not just the structured, unstructured information dissection that we saw just for invoices. Honestly, the benefits are much more bigger than that. It reduces the manual documents processing in some cases. ensures the data is reviewed and validated by humans, and also accuracy is not going to be an issue, because here the bot is the one which is actually acting on it. And also another powerful feature is you're actually able to glean that information and catch it if it is in error prior hand before updating the back office systems like SAPs and other things, because here it is upfront known. And it allows humans and bots to work together faster and with higher performance over time. And as an extension, this could be extended to various other domains like supply chain and in the warehouse and various other places. And with that, I would pass it back to Mark for the video to demonstrate these features.
Yeah, excellent. Thank you, Ravi. So the best part, if we could start, actually, let me tee this up. So the best part is to actually see it in action. So you saw the slideware, which was great, but we'll actually demonstrate how these capabilities work in the platform. In the first instance, we'll go ahead and get this started. If we could roll the video, it would be great. So here we're showing how we can actually start the UiPath robot that's already been built to be able to look into a particular file directory and see that there's documents to be processed. We have a number there that we can take, and we can actually upload those to Google Cloud if we wanted to have some storage up in the cloud for that particular document. It can then be further processed by the document understanding AI, and then we can determine whether or not we want to actually look at that document based upon the extraction results. So if we never had seen the document before, and this is for the first time that we saw an invoice, for example, we may not have all the features from the extraction associated with the taxonomy that's associated with invoices. So the human can go in very quickly and actually highlight the actual aspects of the invoice number, the purchase order number, the date, who the supplier is, the details with respect to address information, bill to and ship to, the typical common header type of information that we would see, as well as the subtotal and the total information. So it's a very quick process, again, how the robot can make that available for the human to be able to do this in a very easy UI type of way and then be able to complete the process. So another example is, what if we actually meet the minimum threshold value? So if we uploaded the second document, it goes into Google Cloud, into buckets, then we can see that the document understanding AI is capable of extracting the features there. If it meets our criteria for the minimum threshold level, then we wouldn't necessarily have to have that human loop process to be able to exist. The document can continue along its way. If we have another document that we take through here to demonstrate the table capability as well, as Ravi pointed out, that's a really powerful feature here to be able to actually parse tables. The confidence level might be a little bit lower, but what you can see here from the invoice is the detailed level data that's coming out of the invoice itself. So that's a particularly challenging task to take. Oftentimes it's pre-scripted or templatized, as Ravi mentioned. Here we're just using computer vision and the ML type of capabilities to be able to detect that information, parse it out correctly, and again, through validation station, the human is basically able to see the extraction side by side with the actual document itself for that verification. So another thing that's interesting is just to see, what does a robot see? So there's a JSON payload. We can take that data and naturally we can feed it into something like Google Sheets if we wanted to, and we could see all the data that's coming out of the actual extraction process itself in a human legible type of way, as well as the detailed table data that comes out of that. Or we could use this and analyze it further if we had some reporting or analytics dashboards that we wanted to be able to put up against this data. But more importantly, probably what we want to do is we want to take that invoice data, and we want the robot again now to pick up that data and start to log into SAP on our behalf. So the robot's basically then authenticating with user and password credentials here, automatically knows that it's in the task to be able to input invoice data. It can go to the appropriate screen within SAP to be able to input that data and put all the corresponding information that it extracted from that process automatically. So again, the robot is actually performing these tasks that a human would typically do in the environment without, if we could stop it here, it would be great, without having to necessarily go in and perform that function itself. So what we've demonstrated here really is an incredible end-to-end type of capability. This particular example is for invoices, but it can be applied to any type of enterprise document, unstructured, semi-structured, and structured, and that's another powerful aspect of the platform. is that it can be truly used at an enterprise level. And just finally, to land here, we have different graphings that Ravi showed before as a classification technique. Our time is out. We really enjoyed speaking with you, and thank you very much.
Thanks a lot, Mark and Ravi. That was an awesome presentation. And thanks a lot for being a great partner. So next, I would like to introduce Avi, SVP of Product and Engineering or Automation Anywhere, and Gans, VP of Digital Experience and Insights at Infogain.
Hey, thanks, Francisco. All right, guys. So we are from, I'm from Automation Anywhere. And we are, again, one of the leading vendors in this entire space. We are the ones who actually coined the term digital workforce. And the idea is just like a human, you actually execute on things or do work, then you think about things, you analyze things, and you go drink tea or coffee. Well, there is a digital equivalent to that, and that's actually what our product portfolio consists of. So we have our core enterprise RPA platform. The bots they can work with 400 different types of frameworks. They can actually, the way I put it is bots can see a couple levels deeper than a human can, and they are less likely to make mistakes, right? So the core RPA platform can work with any of the applications that are out there. Then we actually have had a cognitive component to our product line since the last 4 years. And we can, again, we have several applications of that, including understanding documents as well as processing documents. We have a bot store that is public and open, where you can find 30 to 40 different domains with all kinds of different documents being processed. We also have a smart BI platform that actually gives you real-time, not just operational insights about the bots, what each of the bot is up to, all kinds of bot security analysis as well. But what we do is we also work with the content that is processed by the bots, and that gives you real-time business insight. So we believe that RPA can actually play a major role in for you to spot business opportunities, and it's not just about cutting down process costs and cycle times. So this together is the digital workforce. The digital workforce is available to you in our bot store by process or by digital workers. If you look at any business process, it consists of these steps with respect to data. You are either capturing the data, or you're enriching it, validating it, processing it, reconciling it, and analyzing and reporting on it, right? So traditional RPA, while it goes all the way, while it tackles majority of the steps, AI is still needed in several different aspects. So we have AI embedded in the core platform. So core computer vision based on deep learning that will actually, even if we don't understand the framework, even if we treat the screen as a giant image, the bots are still able to work 100% reliably. But we have expanded this and formed this true partnership between RPA and AI to be able to embed any AI models. So one of the highlights of the platform is the fact that you can actually embed traditional, you can embed AI models from providers such as Google, as well as you can have custom AI models that you build yourself. So for example, running a Python script and so on, right? So we are delighted to be here. We have partnered with Google at a very high level. And it is not just about using Google AI, but it's also about running bots in the Google Cloud, and finally, humans interacting with the bots through your Google Productivity Suite. So we have a very interesting use case here, and here to talk about that use case on how we have leveraged the Google Computer Vision API to prepare for 10x growth at a customer where achieving this kind of transaction growth was just not possible without using bots. And so here to talk more about it is Gans from our partner, Infogain.
Thank you, Abhijit. Quick note about Infogain. We are a 30-year-old software engineering firm. We are based down in Los Gatos, and we've got offices all over the world. We are partners with some of the leading technology companies, and we assist Fortune 500 companies on their journey to digital. We are partners with Google and with Automation Anywhere, and we'll talk about a very interesting case study that we've got here for our customers. What we're going to talk about is a customer here, which is basically the world's largest travel marketplace, and they've got more than 400 million guest arrivals per year on their web properties and mobile properties. And one of the interesting problems they had was the customer segment where you had more than 10 properties that you wanted to transact on their platform. These properties, if you ever went through their website, you would see that there's almost 10 pages of data that you have to provide in order to list your property on their platform and go through all this stuff. So highly manual process, took a lot of time. It took up to 30 days for the entire process for your property to be listed, of which 5 to 7 days was just the data part of it. And though there was a lot of onboarding assistance provided, the whole onboarding assistance was provided manually. So you had to call up a team, the team would go through it and stuff. What was causing a lot of friction in this experience for the customers was basically the fact was, because this was a manual process, they were seeing a very low activation rate. Activation is the process from when you sign up to have your property on the site to actually doing the transactions on the site. And that was in the low 30s as an activation rate. And that's primarily because of, A, being a manual process, you had poor data quality. So, you had a lot of errors in the data that was being processed. There was incomplete attribution, so you couldn't run those metadata to run campaigns and promotions and search. And this process was being done on a much smaller scale of volumes, and the customer was anticipating 10x growth, and this was just not a scalable process for them going forward. And when we worked with Google and Automation Anywhere to help this customer, there was one simple goal that they had, which was, how do we optimize the conversion funnel? Which means if I sign up number of customers on this site, I need them transacting more and more. That was the primary thing. So if you look at the conversion funnel, there are 3 steps in the conversion funnel. One is you have to create a listing on their site with their property, and then put it in front of more users out there. And the third thing was, how do you create more and more better data so that you can run promotions and search? So this was the goal with which you did it. And that's where we first brought in the robots that Automation Anywhere was, and we hosted that on Google Cloud. And we basically had the robots doing the listing creation and also the gathering the data so that a lot of that can be automated and someone does not have to do it manually. And once that listing was created with all the data in it, it went to a human person, a team out there, which approved the data, put the listing data out there. And once that was done, we used the API integration into Google Cloud to basically transfer the data to the web property that our customer held. And once that was done, the listing was happening for the website. And this was earlier being all done manually without APIs and without a cloud infrastructure, is all being done automated. Once we did that and we started seeing some benefits for our customer, we moved on to the next stage of the project, which is basically the fact that you've got something automated, you've got something, how do we scale this automation, right? So scaling the automation had 3 basic parts to it. As you can see, the first thing is, in the first phase, we already improved the turnaround time, and we made it a self-service. So we also integrated Jira into the Google Cloud infrastructure so that customers can look at their own tickets and figure out where the property was in the whole process of onboarding. But we also wanted to move this to international scale, move it to more countries. And that's where Google Cloud's whole scale and infrastructure came into play. And for them to roll it out to multiple countries was much easier. And the last stage of the product was to basically use Google's AI services to see how we can monetize the metadata that we can pull out of the properties, and how do we move it to new product categories and new language categories in the sense of how can we use NLP, how can we use language translation services that Google has so that we can move this. And this was the roadmap that we used working with Google and with Automation Anywhere to move the customer to a larger scale. What we particularly used about, and I want to talk about here, is we actually embarked on a very fast and effective integration of AutoML vision models into the existing robots and the process. This is a whole project that we did in 8 weeks that goes to show the ease of use and of the AutoML product. And we basically took all the properties that they had. We took 1,000 images. So each property comes with some images. And in the previous world, someone had to sit at the images and look at each image and see which amenity was in the image, right? And amenities are very important if you ever tried doing a vacation rental or a hotel, because you want to see the property, you want to see what it is in it, whether it's got a microwave, whether it's got a fridge, whether it's got a bathtub, and that's so more so in the international market. So we took the 1,000 images, we did the training on the images, and we did multiple iterations, 5+ iterations on the training. And each iteration took around 2 to 4 hours of model training time to do that. So it was fairly swift, fairly good to do it. And we looked at 3 to 4 major amenities out there: TV, bathtub, and a king bed, because that's based on these amenities. The pricing recommendation engine of our customer could actually recommend more effective prices that you should be charging for your properties, right? And in 8 weeks, we were able to demonstrate a 90% accuracy and upwards of 90% across all categories that we see out there. And that's where the AutoML vision was not only fast and efficient, but it was very effective in generating the data that the customer wanted. The customer had, if you look at what the customer was looking at, going back to the problem statement that existed out there, one of the things was this customer was doing this entire process manually, which means they were probably taking a month to do this entire process, of which just the data capture part of the property was 5 to 7 days, right? And in that 1 month, if you know anything about properties, in that 1 month, you lose your customer because he's focused onto something else and stuff. And that's where the activation problem really came in, right? Because they were, in a month, you were losing them. You didn't know where the property was. And activation was also missing because, like I mentioned earlier, the amenities data was not there. A lot of metadata was not there for them to promote their property. Able to demonstrate a 100% increase in the activation rate, which is direct revenues for the customer that exists out there, right? So that's something that we were able to do. The total cost went down 40%. I mean, being a digital unicorn, they really never worried about cost, but it's very important as you scale the process. You want to make sure that per transaction and per property, your cost goes down. So we were able to demonstrate a 40% reduction in cost. But I think to me, the most important fact was, and which was causing the biggest friction among the users, was we were able to turn around, the turnaround time was reduced by almost 70 to 50%, which is basically the fact that something which took 5 to 7 days was being done in 2 days. This is very important for them because they could get back to their property managers fast and tell them that, hey, we signed up you, you're on live and stuff like that. And last but not the least, I think as you move a process to scale, they were looking at upwards of 150,000 properties over a calendar year to scale up to 1 million plus and stuff. It's very important that they go about doing this in a self-service model. So for example, if there are exceptions happening, if there are things that are, something needs to be changed, something needs to be done offline, we really put in a self-service automation module in place. And this is where, the ability of integration with Google Cloud and Jira and the RPA robots really came to speed. It was not a custom project. We could do that very quickly. It did not require, generating custom APIs and stuff. So that's something that we did it. And by doing all this, like you see out there, I talked about it, it's 96% accuracy and 90% recall is what we came up with the training model. So this is now being implemented across all countries. And the future state is we're going to increase it across multiple amenities so that, as you go across using these properties, you will see that this is going in a much faster way than you can. This is one of the use cases that we have seen with our customers, and Google's object detection AI was very useful to it. I'm just going to turn it on to Abhijit to talk about other cases that we can come across.
This is amazing, right? I mean, what can bots do next? I think what I like about this is it's the application of computer vision, but it's also the realization of quick results. Given that this entire project was done in about 8 weeks, it really prepared the customer to be to scale their number of transactions with bots. And that's one of the key value props that RPA brings to the table, is that RPA plus AI will give you a completely new level of ROI, because RPA helps AI by bringing in 3 ways. It brings data, it brings training to AI, as well as it brings the business context to any of these services. So that's just one of the use cases. We have plenty more that are actually scattered across different verticals. So if you want to learn more about this, please visit us at our booth. We also have a video of this process with the bots in action, where how they actually go from that beginning of the property listing all the way to recognizing all of the different objects in there and being able to provide a response, and then human in the loop, right? So the same concepts of having the confidence threshold and all specified, and if it is below a certain threshold, a human needs to be in the loop to be able to review and train the bot further, right? So this is basically AI as it learns, becomes better, and the bots can actually manage more and more by themselves, requiring little or no supervision eventually. Like I said, visit us in our booth. It's booth 1660 in Moscone South down here, and we can talk to you about several other such use cases. All right, thank you guys for attending. Francisco, I don't know if you wanted to say. Thanks.
Thank you very much. Just to wrap up, I wanted to invite you to go to cloud.google.com/document-understanding-AI. If you want to learn more about these capabilities, sign up and be connected to one of our Prime partners. Thank you.
There's nowhere else you wanna be. else.